Anyway, welcome to the ION part of the agenda, or ION part of the program. ION is a series, or IONs are a series of technical conferences that are organized by the Internet Society. We do this in various places around the world, usually around 4 each year, and we decided for one of these this year that we would co-locate with RONOG. So we'd like to thank the RONOG people for kindly agreeing to host us here in Bucharest. We're very pleased to be here, and hopefully we can relate a lot of the technologies and internet standards development activities that we're involved with, but hopefully also the Romanian internet community can be involved with as well. So, I had this question already several times since I've been here. So what exactly is Internet Society? Well, just to be clear, just to introduce myself and my colleagues. So I'm Kevin Maynell. I'm working for the Internet Society Global. So you'll also have a number of national chapters as well that you'll see and hear about. There's one in Romania. My colleague Jan Zorj is sitting there, and my other colleague Dan York is also working for the Internet Society Global. So what we are a global organization of members, chapters and partners that aims to promote the open development of the internet for the benefit of everybody. That's why we're here. This takes a form of encouraging open development of standards, protocols, and also in terms of internet governance as well. We're here to provide reliable information about the internet. We had a very interesting discussion earlier today on the benefits of IPv4 and IPv6. That's one of the things we aim to be involved with. But also to lead the lead discussion of issues that affect internet evolution and developments. And then we also have a role in encouraging growth of the internet in developing countries for education and training. That's less applicable in Romania, but that's something that we do in other parts of the world. And then generally encouraging participation in internet administration, internet governance, internet developments. So we sort of have these 3 strands, policy, technology, development, which all intertwine. You'll probably be pleased to know we're not going to talk too much about policy here. We're here to talk about technology. But this is just so you're aware that we cover all these areas within the organization. ISOC was founded in '92 by Vint Cerf and Bob Kahn, who I think pretty much everyone is aware of. And we are an international not-for-profit organization. We are the organizational home of the IETF, so we're there to provide support to that organization. And as I mentioned, we're a global organization. We have a global presence. There's more than 110 chapters worldwide, including in Romania. 80,000 members and supporters, 135 plus organizational members. And then we also have 6 regional bureaus to support the work that we do around the world. There is a European bureau that's operating out of Brussels. And in terms of the number of countries we actually physically based in, this figure is probably actually slightly incorrect. I think we're closer to 26 countries from where we're operating. Not sure if we have offices in all of those, but there's certainly staff in all of those countries. So primarily we're here though for the Deploy 360 program, which is an initiative of the Internet Society, and it's under the program under which the ION conferences are organized. So just to give a very short overview of that, the idea behind this is that the IETF creates protocols based on open standards, but these are often not known or widely deployed, sometimes for good reasons, but other cases it's a lack of awareness. So about 4 years ago, when this initiative was set up, it sort of became clear that people were looking for sort of clear and concise information about how to utilize the IETF standards and how to deploy these. So Deploy 360 was an approach to basically try to provide hands-on information about IPv6, DNSSEC. Those were the two technologies that we initially focused on. And we've extended that to trying to promote or deploy, more widely deploy TLS, and also improve the security of the BGP routing system as well. So what we do, we go out and work with the sort of early adopters of these technologies, and we create technical resources, which are available sometimes. Well, we put these on the internet, on our website, but we also go out with these ION conferences. We also go out to other NOG events to discuss these case studies, provide practical information on how to deploy these technologies. So we currently have 3/4 members within the team. I already introduced one of my colleagues there. Dan is actually not formally part of Deploy 360 team, but he works with us very closely. He was formerly a member. He's now in the communications team, but he works closely with us as well. We have another colleague who's not here for this event, Megan Cruz, who actually normally organises these ION events. I already touched on a number of these areas in which we engage with the community. The main one, of course, is a web portal. We also have a log on technologies or interesting developments in technology, which you can read on Facebook and Twitter. We've got some videos up on our YouTube channel as well. We do speaking engagements as well, so although this is an ION conference, this is something that we organise, we also get invited to quite a lot of network operator groups. Jan, in particular, goes out to those groups and talks and provides the benefit of his wisdom from down the years. And as I already mentioned, the ION conferences. So if you're interested, this is the URL of the web portal. I won't go into this too much detail, but we also aim to try to give content specific to these 5 or 6 main categories. So obviously network operators is perhaps a key one, but we're also looking to target developers and content providers, manufacturers of consumer equipment, and enterprises as well. So you go there, you can find information on specific to your specific interest. Dan, I think, is going to talk a bit more about this. One thing we do is also we keep a track of where DNSSEC is being deployed. This isn't just based on statistical information, but also on what we call observed information, so where we know that a TLD has enabled DNSSEC. We see a news report, or we hear something that also goes into the data store. And from this, we produce these DNSSEC maps, which chart the progress of deployment of DNSSEC. So that's the sort of state of play at the moment, but I think Dan will talk about that in more detail in the next presentation. Another thing we work on is best current operational practices. So again, this is the sort of, we're trying to collate all the sort of word of mouth information that people talk about, you know, in halls and in meetings and just inside of head, in the bar sometimes. And what we're trying to do is trying to write all this down and produce what we call BCOPs. This is not our view of the world. These are community driven, community written, community vetted. We're just there to help try to facilitate that process. So it's very much driven by the community. And these number of BCOPs have been produced in different regions of the world. These get periodically reviewed by the global engineering community. So it's very much documents that reflect the real world, not something that we've produced sort of in isolation. The two sort of really active BCOP groups, the one in North America, the NANOG one, that's actually chaired by our former colleague, Chris Grindeman. Perhaps the most applicable one to this region is the Right BCOP Task Force. Again, My colleague Jan Zorsch is one of the chairs of that. It gives you an idea of the type of BCOPs that have been produced, but we actually had a big session, I think about a month ago, where we sat down with a number of people from the community in a room for, I think it was 3 days, and churned out about 5 of these, which I've still got to write up, but hopefully those will be available before the RIPE meeting in a couple of weeks' time. There are activities in other regions, less applicable for here, but it's just to give you an idea that this is a global initiative. We're always looking for involvement. We're always looking for new ideas for BCOPs. If you're interested or interested in starting a BCOP effort, please see our website. That also applies to the Deploy 360 website. Again, this is, we want this to be community-driven. It is community-driven. We really need to engage with the industry professionals to help create this content. If you have materials, if you'd like to produce materials, we'd be very grateful for that. We're very happy to credit you, put that up on the website. So the types of things we're looking for are tutorials, guides, how-tos, reports, white papers, developer libraries, links to useful tools, case studies we're always interested in. These things are very helpful to us. Also, again, we actually don't have any Romanian content on the website at the moment. If anybody would be interested in translating into Romanian, then that would be great too. The ION conference is already touched upon. In the interest of time, I'll skip this slide, but we have 3 or 4 of these per year. So I think there are people from not just Romania in this room, so if you are interested in hosting an ION, please get in touch. So, to today's agenda. So it's a pretty full agenda. Hopefully we'll get through it all. But we're starting up with some information about DNSSEC. So my colleague Dan York will be talking about deploying DNSSEC. And we have a case study, a local case study from the ROTLD, the local CCTLD. My colleague will then be talking about his experiments and practical experiments with deploying Dane using the Let's Encrypt CA. We've got a short presentation after the break on what we call manners and the Routing Resilience Manifesto. So this is about collaborative security in the routing system. Then we move into IPv6. Okay, why do we need IPv6? Why should you use IPv6? We actually had the case for why you should use IPv4, so we'll put the opposite case forward this afternoon. Then we have an interesting panel discussion, which I thought there was already quite a lot of debate downstairs at lunch over this. So this is an opportunity to ask some questions to the esteemed panel. And then finally, just a short overview of what's happening at the IETF and whether you should get involved. So with that, I'll move into the first presentation of the ION. And I'd like to invite Dan York up to discuss DNSSEC. So Dan is a senior content strategist. He's working in the communications department at the Internet Society, but he is formerly our colleague, and he formerly worked a lot on Deploy 360, so he's very well versed in the subject. So with that, I hand over to you, Dan.
All right, so good afternoon. Wish I knew how to say that in Romanian, but I don't, so we'll just go with this. So my name is Dan York, and I'm going to talk a bit about DNSSEC, but before I get going with that, how many of you have deployed DNSSEC right now? Okay, you don't count. You're the next one. Okay, a couple people in here. All right, good. Okay, how many people know what DNSSEC is at all? All right, a few people in here. Okay, well, we're going to talk a bit about this. So first I should mention that DNSSEC is one of the technologies that we at the Internet Society are looking at as ways to bring about a more trusted internet. We're going to hear a little bit more later about manners and about some of the things around routing security. But what we're here to talk about right now is mechanisms that can be used for creating trust in internet identifiers and internet names, And also, we're going to talk a little bit about TLS and DANE and how that comes into play. You'll have more on the agenda a bit later. So it really comes down to talking about trust and how do we trust that the information we get out of DNS is the same information as we have in. Up on the slide here, I have a note about a very real case of this that was found. It's actually 2014, but it was the researchers at CERT identified that somebody was taking a certain amount of email and they were redirecting it through MX records, poisoned MX records, out to somebody else. The mail was actually getting delivered, but in the meantime, it was going to somebody else's servers where who knows what they were doing with it, the type of thing. But this was enabled by the fact that the mail servers received the MX record saying, deliver the mail here, but it was the wrong MX record. They were getting information out of DNS and trusting that in some way. So DNS security extensions, or DNSSEC, is defined in a couple of RFCs. There have been a few more since this time that have done more, but this is what's there. And it talks about making sure the info you get out of DNS is the same as what goes in. Let's just take a little bit. Here's the typical thing we explain about DNS and how it works. You know, you want to go to www.example.com, so your web browser goes off and it asks the DNS resolver. There's a missing piece there. It's probably there's a stub resolver on your laptop or mobile operating system or something. But that goes off and asks your DNS resolver, where is example.com? How do I get there? And the resolver will send back some number. Okay? Now, if it has it in its local cache that's right there. If it doesn't have it in the cache, it's going to do this process where it's going to go out ultimately to the root and say, where is www.example.com? And the root name server is going to say, I don't know, but I know who can give you answers for .com. Then your resolver will go to the .com name server, and it'll say, hey, what's www.example.com? And it will answer back and say, I don't know, but here's who's controlling example.com. And it'll go to that one, the name server, and it'll say, what's www.example.com? And it'll get that answer and come back inside of there. So DNS works on speed. The first answer that comes back is the one that the resolver takes as the correct answer. It's all about speed. It'll send the message out there, it'll go and get that, it'll come back in there. So if an attacker can get to the right point in a network, they can do something like this. They can go out there and they can get their response back quicker to the resolver, so the resolver will pass that information back to the client that requested it and say, you know, here's the correct answer. The worst part about this, of course, is that the cache in the local resolver now has this incorrect information, and it will give out this information for as long as the record is set to expire. So it'll stay there. It's called a time to live. So what DNSSEC does is it introduces a couple of new records. One's called an RRSIG, there's a DNS key, some pieces like this. But basically, it signs the information in the DNS file. It signs that and says, this information is correct. And it puts a signature on there and says, or it says, this is the information, here's a signature showing that this is what it looks like. Now what happens is your resolver checks that information, validates in the terms that we call it. It checks that to see, does this signature match? If the signature matches correctly, then the information's correct. If the signature doesn't work, then it's wrong. Something is wrong. There's some error that's there. So in this picture, what happens now is that when that information gets passed back, it has these additional records that are used in the checking. Now, you might say, well, so can't an attacker just spoof this, right? Send in a signature. It's got a really good, valid signature. It's all happy. The thing is that what's happened in DNSSEC is this process where there are additional records that are inserted at the upper levels, the parent zones in this case, that go and tie it all together so that there's this chain of trust, so that not only is my signature there, but it can check that this is the right key. This is the key for example.com. So we'll go through that. So if an attacker tries to go in there, the validating resolver will look at this and say, sorry, that doesn't work. And it will send back, in this case, a serve fail, which is a domain isn't found, server isn't found, that type of thing. And it will it'll prevent you from getting to that website. Now, again, the whole point of this is ensuring that the information you get out of there is there. There's two sides to it. There's a signing side, which is where you go and sign your domains. How many people have, a couple people said they have signed, do you have signed domains? Those who are using, okay, a couple do. All right, the validating is checking. These are two different things. All of you could go home today and turn on your recursive, your name servers, and have them start checking signatures. You could do that today. All you'd have to do typically is uncomment a line of code or turn on a switch that says start validating, and you would start checking DNSSEC signatures. Pretty much all of this, the basic recursive resolvers that people use, whether it's bind or unbound or Microsoft Windows Server, any of those, they will do DNSSEC validation today. That's something we all can do. It's easy to go and set, and that will start checking and preventing these kind of attacks or things like that. The signing side involves a little bit more. You need to go and sign your zone files, sign the information, and then have some system that will go and keep the signing going. Every time you change the file, it needs to be re-signed. Now, almost all of the authoritative servers, again, things like Bind, Power DNS, NSD, some of those, they all have systems to do the automatic signing. So whenever you change the DNS, it will automatically go and re-sign the files. It'll do that automatically for you. It's more a case of enabling that and making it work like that. Let me talk a little bit about the validation. Right now, about 15% of all DNS queries globally are being validated. If any of you use Google's public DNS, they validate all answers. Comcast in North America does that. Here in Romania, I was delighted as I was preparing to find out that one of your large ISPs seems to validate almost all of its answers. More on that in a minute. So about 20% in Europe, and here was my chart about Romania. Romania is currently validating at 43% of all queries coming out of Romania are being validated. So you all are actually ahead of most of Europe. So good news on that. You know, yes, you can see over there Sweden, Finland, et cetera. They've got higher levels, but Romania is doing quite well in this. When I looked at the stats, it was RCS RDS is one that's validating about 92% of all the queries that were coming out of there. Some of the other ones, I mean, you know the players that are here more than I do, but you can see there's several large ISPs that are doing DNSSEC validation right now. So they're doing the checking side of this. This is information that you can get right off of APNIC, Asia Pacific NIC. APNIC has a stats site. The URL's right down here, stats.labs.apnic.net. You can go there, and if you click from their main map, if you go to this site, the screen shows a big map, but if you then scroll down the page, you can get into the individual areas, and then from there, you can get into the individual countries. And then I sorted this on the column for DNSSEC validations. What's happening over there? I see people looking at this wondering, so what's going on here? Over on the right, on the far right-hand side where it says samples, this is done by a mechanism that Jeff Houston and the APNIC team has where they use ads that appear on the side of people browsing in Google. And they do something where the ad goes and triggers some requests to various different servers, some of which are good and bad, and they can validate that off of this. So the number of samples means that the largest number of people that they've measured from that particular network, or AS. And so usually it's a good sign for the larger ISPs in that particular region because they're being able to do that. But anyway, you can go to this site, stats.labs.apnic.net, if you're curious about this. This is the validation side. So the good news is you're seeing a good amount of validation happening here in Romania already. This other column where it says uses Google PDNS is a measure of how many of those samples use Google's public DNS servers. And the reason that comes in is you get into some countries that have 90% DNSSEC validation or higher, and it's because all of the ISPs don't operate their own DNS resolvers. They just use Google's public DNS in some way. So, but over here, it's a low percentage, so you're actually seeing it's a pretty good use of the own reservers there. So on the signing side, it's a bit more complicated because the person who has the domain, example.com, example.ro, whatever, has to go and trigger the signing of that. Their operator, whoever is using DNSSEC, needs to go and sign that zone, work with it. And then there's another little step that the registrar needs to get involved and transmit what's called there's a little record in there, a DS record that has to go up to the root to tie it all together. There's some pieces on this that we as a community are looking at how to automate and make it a little bit better. But overall, Kevin mentioned earlier, we have some DNSSEC deployment maps that show what's going on. And we're seeing a good number of support out there. Here were some of the top domains that had signed in the past while, the number of signed domains at the second level. Netherlands at .nl is the leader in the raw number of domains, with about 45% of all .nl domains are signed. You can see the list on going down there. Brazil is another place, Sweden. Some of these are going on. You'll see down at the very bottom, .bank is one of these new GTLDs, and as part of what they do, all of the domains that are put up into that new GTLD are signed just as part of it. It's part of what they do with that new GTLD. This is some statistics off of another site maintained by Rick Lamb at ICANN, is the one who does this. So I want to move on and talk a bit about one of the applications of DNS, and we talked a bit about TLS in some spaces, and you might say, I've already got SSL. How do I, what do I need this for? TLS, what used to be called SSL, but we now call it as TLS, is about confidentiality. The challenge, if we think about it in a web browser environment, we get the green lock, which says we're doing a TLS encrypted connection. The challenge is, how do we know if we're using the correct DNS or TLS certificate? How do we know it's the right one? Yes, it validates coming from some certificate authority or CA. But anybody know is there any restrictions on which CAs can sign for which domain names? No, there's a thing here. Any certificate authority can issue a TLS certificate for any domain, anywhere, if you can get them to issue a certificate for you. So you can get into a situation where a firewall or an attacker can give back a correct TLS certificate. You'll see a green lock, everything looks good. But in fact, they're logging that information, they're doing something like that. They're performing a man-in-the-middle attack with TLS. But to the user, it looks like you've got the green lock, you've got that secure encrypted connection. You think you've got it, but it's not the right way. Now, there's a number of solutions that are being proposed for how to solve this issue. I'm going to talk about the Dane one that we're looking at, which is how do you work with this? Because this is a problem. The CA system, the certificate authority system that we have, is very broken in a whole number of ways. There was just a report recently that Mozilla was blocking a TLS certificate that was issued by a certificate authority that was for somebody else. They'd issued it for the wrong person, but it was being propagated out there, and so people could go to this site. They thought they were getting to the correct site, but it was wrong. It's all of this issue. You've got over 1,500 certificate authorities that can issue these things. So what Dane does is Dane says, let me put into DNS either the certificate, the actual certificate, or the name of the certificate authority that should be able to issue a TLS certificate for this domain. So when I'm connecting to https://ronog.ro or example.ro or whatever, I can find out from there, am I using the correct TLS certificate? So what you're doing is then, and if it's encrypted with DNSSEC, you're being able to know that that really is the correct example. So let me look at the browser example again. What would happen here is that now, in addition to the DNS key and the RRSIG, you'd get a TLSA record. And a TLSA record would be this pointer to what certificate should be used for this domain, what should work. A browser that was equipped with DANE could check this and say, wait a minute, you're not connecting to the correct site. And then it could either put up a warning or at least prompt the user in some way, perhaps prohibit it, depending upon that. Now, this is how it could work in a browser. The reality is that the browser environment so far has been reluctant to do this because it adds more time delay, more latency to go and do an extra check. And browsers are all about speed. But one place that this has really taken off has been in email. Because it turns out that if you want to do a secure email connection between two servers, there's no really good way to get the certificate of the other end to be able to be sure that you're getting an encrypted connection in the delivery of email from one site to the other. Jan's going to come up in a little bit and talk about a specific case that he's been working on of doing this with Let's Encrypt, which is a mechanism for generating TLS certificates. But there's now several thousand email servers that are working with this, that are using DANE to provide a TLS certificate to know how to get there. The Bundes, I'm going to mess up the name of it, but it's the German security agency. Just recently issued guidelines saying that to communicate with the German government, they were now saying they were recommending that you should have DANE protected TLSA records, so that you should use this in communication with it. A number of the German mail providers and others are now actually advertising DANE protection as part of what they provide in what they're doing. So a number of places are using this as a mechanism to raise the level of trust that we can provide in email, in how we can make truly encrypted email between servers and work with this. There's a number of resources. These slides will be available so you can go and find them, but you'll be able to go and learn more about this through the Deploy 360 site. We also have RFC 6698 is for DANE, some of the other tools that are out there. I want to wrap up by talking a little bit about something brand new that's coming up out of the IETF that I want to have people be aware of, and that is some work going on around the privacy of DNS. Because what people look at is the fact that when you're going and querying for www.example.com, that query from your local computer to your DNS resolver is going in the clear. And so that can be across whatever your local network, across a larger network, across the internet if you were using Google's public DNS servers. That query can happen out there and can be seen. And you can start to get a log of what's there. You can start to see what's going on. It can be used in surveillance. It's this part right here between your web browser, your local computer, and your DNS resolver. All of those queries right now are visible. So I can build a pretty good track record of exactly where Jan is going if I can watch where his DNS, what he's querying on DNS. So what's happened as a result is that the IETF, the Internet Engineering Task Force, has developed a group called DEPRIVE, or DNS Privacy. And what they're looking at is how do we go and encrypt this connection between the local system and the recursive resolver. This is starting to move, it's been moving along really well. The whole point is really now to run DNS over TLS and to be able to provide that encryption of the connection. This is starting to be available in some of the recursive resolvers that are out there. And so I mention this really to let people know you're going to see more of this work, this happening. This is going to be coming out soon as these kind of things go. With that, I want to just kind of wrap up and say the beauty of deploying DNSSEC is that you can look at raising the level of trust that people have in the services you offer. Being sure that people can know they're getting to your content and your information. If you're publishing information in DNS, DNSSEC allows you to be able to go and say, this is the information that I want out there. You can be sure that people are getting to it. They're not getting to bogus websites or other places like that. You also get the ability to use DANE, some of these new features. What I would encourage you all to do as you head out from here, I'd encourage you to go and deploy DNSSEC validation if you can. If you can do it directly with your IT team, whatever else, All of that is turning on the checking of signatures. You know, if you do that, then a year from now or at the next RONOG, if you look at these DNSSEC statistics, maybe Romania will be even higher than 43% and keep on going up from that. But the checking of the validation is something that anybody can go and enable. The one caveat I'll tell you is this. You do have to then be aware, or your trouble desk, your help desk needs to be aware that a failed validation can cause a problem that people can't get to a website. There have been issues where somebody has gone and on the operation side, they messed up and they didn't renew a DNSSEC key. And so they had an expired key out there, and it wound up causing a problem where people couldn't get to their website, people who were checking this. Okay, there were operational issues like that that happened. And so you just need to be aware when you enable validation, if you're an ISP, if you're doing something like that, that if people call in and they say to you, hey, I can't get to this website on your network, but I can on my mobile phone, what's going on? One of the issues might be you're checking it, there's a real, you're checking that, but maybe the mobile operator is not, or vice versa, whatever it may be. So you just need to be aware of that. But if you go back and enable validation, you will start to get the benefits of the added checking that's happening on here. If you can, sign your domains. We're going to hear a little bit more about things happening in the .ro TLD, and you can look at how can you sign your domains to be able to have those there. Also, I encourage people to go and help promote support of this DANE protocol. Look at how you could use it for your mail servers, look at how you could use it for the other piece of your infrastructure and what's there. I think that's all I wanted to say right now. I'm available for questions. I'm around here, but I'll throw it out now. Any questions right now? Yes, I see a couple. Back there, somebody, do we have a microphone we can run out there? Is it on? Yeah.
Hello?
Oh, there it is. Yeah, it's on. You just have to give it a test.
So I have a couple of questions. Is DANE similar to the certificate pinning mechanism in browsers?
No, it solves a different issue. So he's asking, is it similar to certificate pinning? What certificate pinning is in the browser, the certificate basically pins, as it is. It says, this is the certificate to use going to google.com, for instance.
Or the preferred CA?
Or, well, yeah, and so it says, this is the one that's going to be there. And then if you try to get there and it sees a certificate that is not that one, then it will say, there's a problem here, you can't get there, whatever else. It's the issue with pinning is a very good solution. The challenge with pinning is that pinning is what's called trust on first use. It assumes that you're getting to the site correctly the first time you get there, and then you get the TLS certificate and you pin the certificate that's there. The challenge can be that if you go to an attacker's website first, you wind up pinning the attacker's web certificate inside your browser, so that when you then go to connect to the real site, it will say, I'm sorry, that's not the correct site because the certificate's been pinned. DANE can work and can complement that by providing that certificate the first time or a second check on the certificate, so then you know you're pinning the correct certificate.
Okay. And the second question has to do with DNS privacy. Mm-hmm. Can this, because all the DNS queries will be encrypted, does this affect on the defense side, the security defense side, the security appliances that rely on checking DNS traffic for potential malware and things like that?
Yes.
This will hide the malicious traffic as well.
This is one of those things this is why I raised this, is because for the folks doing DNS appliances or doing DNS security services, things like that, they need to be aware that this is coming, because if it does do the encryption between the client and the resolver, then yes, anything monitoring that local network, okay, for any kinds of compliance issues, things like that, other stuff, they will have they will have the inability to get to the information. So yes, it will affect it.
So building block lists or blacklists based on DNS will not be viable anymore.
Well, now, except of course that on an enterprise, for instance, in an enterprise network where they have control of the machines, et cetera, I mean, they always have the option they could turn off that encryption between the client and the local recursive resolver, if they wanted to. So they could there's other ways an enterprise could solve that. Okay. Next question.
How
much time do I have?
Well, I'd say one more question.
Okay.
Thank you. One question. Right now, DNSSEC is a major vector for DDoS amplification. Is something being done about that? I mean, RFC to force TCP responses for DNSSEC or something like that? Thank you.
Yeah, I mean, so DNSSEC is certainly one of the mechanisms there. You saw in the earlier presentation other mechanisms like NTP, other pieces like that. I mean, it is one of the challenges that we have in general with this is that the larger size DNS queries that we're getting are being used as amplification mechanisms. So yes, I mean, you know, forcing things, moving things to TCP is one mechanism to do that. I mean, this is one of the realities that we do have to work with in general as larger DNS packets are coming along.
Yes, but NTP is solvable. The NTP amplification problem
Yes.
is solvable. But DNSSEC is an ongoing problem.
It is. It is.
Nobody implemented.
So, I mean, it is, DNSSEC in the amplification question is a challenge that I think the larger community is still working on. DNSSEC alone is not one of the, I mean, we're also getting the issues where we have just larger packet sizes because we're working with IPv6 answers and other pieces around this. So it is a larger question in general.
And the second question about the delay in response to the clients. If we do the DNS verification, DNSSEC verification, how would this impact the delay? It's increased 10 times the delay to our customers or something like that?
I think the regular DNSSEC validation does not introduce very much of a delay, you know, in terms of what you're doing. I mean, if you look at, and it's being used heavily in production, you know, where I am back in the United States, Comcast has turned it on for their 20 million customers that they're doing within the United States, and have had no issues with that, you know, no kinds of problems with that. So it's being used very heavily in real live production issues without, you know, concerns that people are seeing. So
they use special hardware, SSL offloading or something like that? Or?
I'm not sure what when they were here talking about it, I think they've got their recursive resolvers. I don't know their exact setups that they're using, but
Okay, thank you.
I think I saw one more question.
Well, yeah,
Okay.
maybe we need to draw it to a close here. Okay, well, if it's a quick question, one more quick question. Sorry, was there someone else over here that wanted a question?
Can DNSSEC solve the issue of the man-in-the-middle attack?
Well, it protects against one man-in-the-middle attack, which is the DNS man-in-the-middle attack. So it prevents it prevents somebody from spoofing the packets and redirecting you to another website. So if you think about phishing emails or things like that,
How can it do that? I mean, I can rewrite my client's traffic, the DNS traffic, and lie to him about everything.
Right, but if the client is checking the DNS, so I guess it depends. Are you the recursive resolver?
No, but I'm between his resolver and the internet.
You're
I have
between-
compromised a machine between his resolver and the internet.
Yes.
And I will lie to the resolver, and the resolver in turn will lie to the client.
So if the resolver is doing DNSSEC checking, and if the zone was signed, then the resolver should
Yes, but I can lie also about the signature.
no,
How come?
because that goes into the chain of trust that happens. And so you could create a bogus signature, and you could put it on there, but the signature will not be signed by the key for the domain. So let's say you're trying to spoof the RONOG site, okay, and you were doing that. If RONOG.ro was signed, it will have a signature of its key that goes up into .ro.
Yeah.
And all from that.
Then the client will ask the TLD about the signature, right?
Yes.
But I will lie for the response of the TLD because I'm in the middle. I
But-
intercept all the traffic.
But then you will lie, it'll go up to the top level of the domain. So you'd have to spoof
Which
for
I
this.
will intercept also and lie again.
But then here's where it is. The local resolver has a hint file that shows the top level root key, and so you
Yeah,
can't
okay.
spoof that. So the chain will break there. So you can try.
I will.
You could try it.
I will.
Okay, all right.
All right, I'm being called off.
Okay,
Glad to talk to y'all.
if you... Dan. Dan's here. So we already heard, yes, Romania's a kind of success story with DNSSEC. So let's hear from the people themselves who are doing this in Romania. So I'd like to introduce Catalin Lianca from ICI ROTLD, who will well, give us a case study of what they've been working on.
Bună ziua, numele meu este Cătălin Leanca și lucrez pentru Registrul Național de Domenii.ro, ROTLD. Astăzi am să vă vorbesc despre etapele, despre pașii întreprinși de noi în implementarea protocolului DNSSEC pentru zona.ro. Pentru început, o să fac o scurtă introducere pentru cine nu știe cine este ROTLD și ce face. Și Registrul ROTLD este un departament în cadrul Institutului Național de Cercetare și Dezvoltare în Informatică, care la rândul lui este o companie de stat în coordonarea Ministerului Comunicațiilor și pentru societatea informațională. Ca istorie, ICI a fost primul operator a unei conexiuni internet din România, începând cu anul 1992, la fabuloasa viteză de 9,2 sau 6 kilobits pe secundă cu o linie închiriată cu Viena. A fost și, tot începând cu anul 1992, și primul ISP din România pentru rețelele de instituțiile de cercetare și educație, începând cu 1993, în februarie, mai exact în februarie, 26 februarie 1993, IAN a delegat autoritatea pentru înregistrarea domeniului .ro către ICI București, și asta și datorită eforturilor domnului inginer Eugen Stăicuț, care am plăcerea să-l avem printre noi astăzi. Dânsul vă poate povesti mai multe de istorie, dacă... Despre registrul RO, este un registru așa zis deschis. Orice persoană sau entitate poate înregistra, are permisiunea să înregistreze un domeniu.ro. Registrarea se face pe baza regulii primul venit, primul servit, în principiului primul venit, primul servit. Momentan nu se plătește o singură taxă de înregistrare, așa numită taxă de înregistrare. Nu se percepe nicio taxă suplimentară ulterior de reînnoire și așa mai departe, care noi, ca registru, considerăm că este o problemă. Poate suntem printre ultimele registre din lume care sunt în această situație și ar trebui schimbată. Dar, din păcate, noi suntem să spun așa, la mâna reglementatorilor, Ministerului, care poate lua aceste măsuri. Înregistrarea unui domeniu.ro se poate face direct pe site-ul nostru sau folosind unul dintre cei peste 90 de registrari. Registrarii pot înregistra domenii și în timp real, folosind API-urile puse la dispoziție, EPP, REST, sau interfața de web pentru registrari. Ca o evoluție a numărului de domenii.ro, începând cu 1992, 94 apare aici pe slide, ultima este din decembrie 2015, unde vedem aproximativ un număr de 850.000 de domenii înregistrate. Astăzi sunt 890.000, deci undeva o creștere de 40.000 de domenii în ultimul an. Acum despre DNSSEC, pașii urmați. Am început acum 4 ani, destul de târziu. Prima fază, o numim noi experimentală, în care am încercat, o să prezint mai în detaliu în slide-ul următoare, în ce am constat acești pași. A fost o perioadă destul de lungă, de aproximativ 2 ani de zile, sau chiar mai mult, în care, practic, nu a fost nimic, nu a intrat nimic în producție, numai teste și o să vedeți mai departe în ce au constat. În ultimul an ne-am mișcat destul de rapid, eforturile noastre s-au concentrat, reușind în 17 mai să semnăm zona RO, apoi pe 6 iunie am adăugat înregistrarea DS în RUT și la nicio lună am dat drumul în producție pentru toți clienții noștri. Oricine poate să-și adauge înregistrările DS în baza de date RO. Așa cum v-am spus, am început cu anul 2012, când am început să ne familiarizăm cu această tehnologie, am frecventat niște cursuri, niște sesiuni de training la RIPE NCC și la registru.se, care făcuseră la acel moment pași importanți în implementarea DNSSEC. Și la începutul lui 2013 am reușit să punem în picioare primul testbed, așa zis testbed, operațional, deci cu zone reale. Aceste zone au fost niște zone de revers, deci erau tot lanțul de încredere se verifica și cu niște zone NUM. La acel moment, acest prim testbed a constat într-o soluție folosind bind și un soft proiectat și dezvoltat local la noi pentru managementul cheilor. În timp ce testam această soluție, ne-am dat seama că ea nu ne satisface pe deplin și am încercat să testăm și alte pachete de software pentru semnare și managementul cheilor. Al doilea testbed a fost operațional cu așa numitul OpenDNSSEC, pentru cine e familiar, pe atunci versiunea 1.4 și ca storage pentru chei soft HSM. La acel moment, zona RO era deja activată avea enable pe Dynamic Updates. Acest lucru a constituit o problemă pentru că OpenDNSSEC-ul în acea versiune nu suporta Dynamic Updates. Următoarea soluție aleasă a fost folosind bind cu AutoDNSSEC Maintain, care face semnarea automată, on the fly, chiar și mulându-se foarte bine și pe sistemul de Dynamic Updates. La acea vreme, bind-ul nu avea însă sistemul de management al cheilor, de rotire al cheilor. Am început să dezvoltăm un sistem tot propriu, care se baza pe o soluție, pe baza de date și backend-ul de la OpenDNSSEC, deci partea de management al cheilor de la OpenDNSSEC și Java. După ce această soluție a fost operațională, să spun așa, în testbed, ne-am decis, următorul pas pentru intrarea în producție era folosirea unui HSM hardware pentru securitatea cheilor. Sistemul ales a fost Thales Shield Connect. S-au demarat procedurile de achiziție încă începând cu anul 2014. De ce am ales această soluție? Pentru că bind-ul avea suport oficial pentru acest tip de HSM, și cu modul PKCS11 nativ, fără să depindă de librăriile OpenSSL, care și la acea vreme, adică aduceți aminte de ce probleme a avut. Avantajul acestui HSM, mai erau câteva din avantajele lui, folosește un așa numit security hold, care nu este efectiv, deci el este răspândit pe mai multe sisteme, care permit un spațiu de stocare a cheilor practic nelimitat, o ușurință în efectuarea backup-urilor, așa numitului Remote File System, RFS. Sistemul permite load sharing pentru operațiunile de criptografice. Au fost luate măsuri și de întărirea securității fizice ale ASM-urilor. Între timp, au fost luate și alte măsuri, să spun așa, și alte eforturi cu privire la activarea suportului sau upgradarea aplicațiilor ca să suporte DNSSEC. Mă refer la bazele de date cu domenii, sistemul de middleware, API-urile REST și EPP și nu în ultimul rând aplicațiile de frontend, pagina web care este accesată de registrați și de clienții finali. S-a făcut și un audit al infrastructurii de rețea ca să vedem dacă nou tip de pachete este suportat, nu este filtrat, nu este dropat de vreun echipament, în special de firewall-uri. S-au pus la punct și niște tool-uri de monitorizare continuă care să fac monitorizarea serviciilor de semnare și de validare ale zonei, folosind tool-uri open source, Nagios, Cacti și alte tool-uri dezvoltate local. Ultimul design ales a fost cu Bind, un hardware HSM de la Thales, așa cum am spus mai devreme, backend-ul de la OpenDNSSEC și un software de management al cheilor dezvoltat local. Ca schemă, de principiu, avem baza date RAW, un sistem care generează efectiv fișierul de zonă nesemnat, care intră într-un sistem de semnare care constă din bind, care comunică nativ cu HSM-uri, sunt de fapt două HSM-uri care lucrează în load sharing și load balancing. Acest bind trimite zona semnată către name serverul ascuns, care face mai departe distribuția zonei semnate către name serverele publice. De ce a durat așa mult? În primul rând, începând la acea vreme, în 2012, nu a fost considerat un proiect cu prioritate mare. Alte proiecte de genul refacerea sistemului de înregistrare, introducerea IDN, actualizări sau upgradări ale arhitecturii hardware au fost pe primul loc la acea perioadă. Nu am avut nicio echipă dedicată pentru această dezvoltare până în 2015. Perioadele de timp la care s-a lucrat pentru această implementare au fost intermitente, tocmai din considerentele de mai sus. Au fost testate mai multe soluții software pentru a vedea diferențele între ele, performanțe, eventuale probleme care pot apărea. De asemenea, o foarte mare problemă am avut cu achiziția de HSM-uri. Aproape o jumătate de an ne-a fost întârziată achiziția lor. Și, în ultimul rând, am urmărit ca sistemul final, varianta finală, să aibă un risc cât mai mic de apariția erorilor în producție. Acum, ultima, o să spun așa, ultima politică de chei care am adoptat-o la semnare a fost pentru o cheie de zonă de 1024 de biți, care se rotește la 90 de zile, o cheie de pe 2048, acolo, greșit, rotită în fiecare an. Zona a fost semnată cu NSEC 3, opt-out și semnăturile au o validitate de 30 de zile. Pentru clienți sunt acceptați aproape toți algoritmii de DS, hash-ul tipul 1 și 2. Primul domeniu semnat, bineînțeles, a fost rotele.ro. Ce observăm astăzi este foarte puțin folosit. Deci din iunie până acum avem aproximativ 150 de domenii, ce reprezintă nici 0,02% din totalul de 890.000 de domenii înregistrate. Ce ne propunem? Să organizăm workshop-uri și seminarii pentru oricine dorește, în special pentru registrari, care ar trebui să ia primele, să spun așa, măsuri și să creștem pentru creșterea și sensibilizarea acestui în comunitate. Cam asta a fost prezentarea. Dacă aveți întrebări.
Okay, thank you for that. Are there any questions? There's one at the back there. Okay, try this.
Mulțumesc. Ce se întâmplă când îți expiră cheia? Dacă nu, să zicem, semnezi...
Cheile nu expiră.
Dacă expiră înregistrarea.
Care înregistrare?
Deci când înregistrez un domeniu, dacă vreau să am și DNSSEC, trebuie să-mi public cheia publică sau...
Nu, se publică hash-ul cheii de cheie, numit DS.
Care are valabilitate cât? Și când expiră...
Indefinit. Nu are termen de expirare.
Nu expiră o dată pe an sau la un an? Sau...
Singurele care expiră sunt semnăturile, care, v-am spus, durata lor de viață au 30 de zile, by default. Ele sunt reînnoite la 23 de zile, deci când mai sunt 7 zile jumate, asta este setarea default a bind-ului, noi am lăsat-o așa, ele sunt reînnoite de către noi. Politica de rotire a cheii pentru zona noastră o stabiliți noastră. Deci noastră decideți când să faceți rotirea cheilor. Ele default nu expiră niciodată.
Ok, deci nu am problema că dacă mi-a expirat nu mai merge deloc domeniul. Ok.
Nu.
O altă întrebare oarecum legată. Cu alt tip de soft în afară de bind ați încercat? De genul Power DNS? Sau...
Power DNS nu l-am încercat, am specificat în prezentare OpenDNS.
Ok, mulțumesc.
Deci OpenDNS are și motor de semnare și motor de management al cheilor. Bind-ul are motorul de semnare implicit și acum în versiunea 9.11, a apărut acum câteva luni, au introdus și un soft de management al cheilor, Key Manager sau ceva de genul ăsta.
Mulțumesc.
O scurtă întrebare vreau să spun și eu. Ziceai mai devreme că ministerul trebuie să aprobe introducerea unei taxe anuale. De ce? Pentru că mă gândesc, de ce te întreb? Pentru că mă gândesc că dacă ar exista o finanțare anuală de la clienți, poate v-ar ajuta să se rezolve mai repede toate problemele astea și să existe mai mulți bani pentru investiții. Că toată lumea taxează anual. De ce la voi trebuie să aprobe ministerul chestia asta și nu e suficient să decideți
Pentru că ăsta este cadrul legal. Conform HG-ului și de funcționare, reglementarea intră în atribuțiile ministerului.
Da.
Și asta e corect. Dar... Da, mai multe detalii nu pot să vă dau. Eu sunt pe partea tehnică mai mult.
Da, câteva întrebări oarecum legate de întrebările dumnealui. Cât de ușor este să revoci cheile? Există un mecanism, cum e CRL-ul la certificate sau OCSP-ul care poate verifica revocările. De exemplu, dacă vrei să revoci o cheie pentru că a fost compromisă, cum alertezi toți ceilalți că cheia a fost revocată, dintr-un motiv de securitate, de exemplu?
Deci, referitor la chei, noi, ca registru, avem în baza date și implicit în zona RO doar înregistrarea DS, da? Deci care este un hash al cheii de cheie. Dacă dumneavoastră aveți o problemă cu cheia de cheie sau cheia de cheie implică pe noi, că dacă aveți o problemă cu cheia de zonă, nu ne implică pe noi ca registru ca nimic, ca parent al subdomeniului noastră RO, puteți să faceți un rollover ca orice. Deci dumneavoastră hotărâți cum faceți rollover-ul de cheie și așa mai departe. Deci noi suntem doar un liant între root și subdomeniul nostru.
Și o altă întrebare legată de servere testate. Știu că cei de la registru de domenii CZ au un server CNOT, se numește server DNS, dacă l-ați încercat.
Nu.
Am înțeles.
Can I ask a question? Can I ask in English?
Yes, of course.
I have 3 questions. Why
Everyone has 3 questions.
why just #1 and 2 and not 4?
I don't know.
Okay. The next question is: do you have in plans to support CDS and CDS DNS key? That's an RFC now, where you as a TLD, if somebody rolls the KSK and publishes the CDS in his zone, you can fetch the new DS and put it in.
No plans yet.
No plans.
No.
But you do support in EPP that somebody push in the
Yes.
DS key. Okay, thank you.
Okay, I thought there was someone else had their hand up at some point, but if there's no other questions, again, I'd like to thank you for your presentation, Kathleen. And now I'd like to call up Jan Zorg to the podium. Dan already discussed a little, touched upon the uses for Dane, which is, has a link with DNSSEC. Dan talked about the principles behind that, but Jan has actually gone out and done some experiments and tests. So he's going to talk about, hopefully we'll talk about that.
What kind of file did you put on here?
Well,
oh, it's 0. Do you have a USB key?
Yep.
I'll just run it from the USB key.
On there. So yeah, I mean, so this is while Jan's fiddling with the USB key. Yeah, I mean, this is so Dane is one of these protocols that the aim is to really to address some of the shortcomings of the CA PKI system, the global PKI system. Let's Encrypt is a relatively recent initiative that was launched to provide automated or to allow automated ordering of digital certificates.
It's 0 bytes long.
You remember what you talked about? Start talking and I'll...
Okay, I have this thing. Meanwhile, while Kevin will provide you with a nice presentation of mine that worked many times already. So I'm Jan, I'm from Slovenia, I work for Internet Society. But in my past, I actually started the not-for-profit organization called Go6 in Slovenia that is aiming to provide, to raise the awareness of IPv6 and implementation of IPv6. And as part of this organization, oops, don't break things. As a part of this organization, we also built a lab for IPv6. It's called Go6 Lab, where we were testing, and we are still testing lots of IPv6 development, lots of IPv6 products, systems, mechanisms, new protocols and things like this. But since, years ago, we were quite busy with testing all this stuff. But now, lately, it just became boring because IPv6 just works. And I know at least one person will not agree with me. It just works. So now we are, well, it is getting better. So, okay. What happened was that I was seeing less and less need for so much testing of IPv6, and then I got bored in my lab. And I said, okay, what should I do in my lab? It's 3 racks of equipment with all these servers, routers, and everything. Then I know I need to do something with this, right? And I said, okay, what is this DNSSEC and DANE and TLS that we are talking about more and more? And before I started exploring the DNSSEC, it seems to me that it is very complicated. Now, I've been in internet business for 20 years. I was running DNS servers. But this seemed to me a sort of like academic project that is so complex and hard that I will never understand. After I did it, now I see how easy it is. Okay, first of all, the acknowledgement. I would like to thank Internet Society to let me spend my working time for ISOC in my lab and doing all these tests and crazy stuff in my lab, so I'm able to put together presentations like this and talk to you about this stuff. So, as I told you, I got bored in the lab. So what did I do? So I have this Power DNS server that was mentioned today. Does this work? Yeah. So I have this Power DNS server, and it's used as a primary non-signed domains server. It was used before because I was serving for the non-signed domains. And now all of a sudden, it became a hidden primary. I went with a little bit different architecture than your TLD. You will see it later. And then I said, okay, let's use OpenDNSSEC signing platform. Why? So, okay, the primary reason why I started doing this was because Matthijs Mecking, back then he was working for NLNet Labs, and he was actually one of major coders for OpenDNSSEC, asked me at one IETF meeting, Jan, why is Go6.si not signed? And I could not provide him the good answer because, you know, I said, yeah, well, you know, the only thing that I could say is, you know, Matthijs, this thing is enormously complex. I don't know how to do it, but I promise, if you put together for me a document, deployment-oriented document, without all this academic complex stuff, just deployment-oriented document that says, install this, edit this file, this is how you add the domain, this is how you publish the domain, then I will do it. And actually, that's why I chose the OpenDNSSEC, because he wrote for me the instructions for OpenDNSSEC platform. Then I'm using bind9 DNS servers as secondaries. I'm changing them to unbound these days. Don't ask me why, I just decided in my head that I need to change them, at least one, to have some sort of diversity. So the virtualization used was Proxmox 3.4. Now it moved to Proxmox 4.2. It's an excellent virtualization platform, and it's free. And OS templates, so for OpenDNSSEC platform, I used Fedora 20 because it's very well supported and maintained there. And CentOS 6 and 7 for the other things. So I put it in as a bump in the wire. I have 2 public primary servers, and the concept should be here, but it's not. Dude, seriously. Okay, so there should be a picture of hidden primary, OpenDNSSEC in the middle, and then 2 secondaries that are acting as primary and secondary and public-facing servers. Okay, I deployed it. I used this document that you can find on this URL. It's sort of like 4 or 5 pages. It's very simple, very short, and to the point. I was following this one, And I deployed it, I signed the domains, I published the DS keys, done. Now what? Okay, my domains are signed. Okay, now they're validating, and I'm happy, I'm happily sitting in the lab. And I'm bored again. Okay, now what can I do with this? Okay, now I secured the zones. And I said, okay, let's go into this Dane. So Dan was talking a lot about Dane back in days, and I was like, okay, let's test this thing. So I went and read. And actually I realized that Dane is just basically one additional record in my DNS zone file. It's called TLSA. I said, okay, how hard can it be, right? So what is the requirement? Of course, DNSSEC signed zone. You cannot do Dane without DNSSEC because the information you provide is not verified if you don't do this. Then I was thinking, okay, should I do the experiment for the web or for mail? I said for the web, okay, for web, current browsers do not yet support it from the start by default. But there is an email server, it's called Postfix, that implemented Dane function. So I said, okay, let's do it for email. Of course, back then, so you need a Postfix server with TLS support that is, and the version of the Postfix needs to be bigger than 2.11. Of course, because then this one was the bleeding edge version. Back then, we decided on 3.0.1 just because I could. So this is how TLS-A record looks like. It's underscore port dot underscore protocol dot hostname. You see, this is my MX server. And this is TLSA is a type. This is a selector. It's 301 or 311, or you need to go into the RFC to read what these numbers means. And this is the hash. This is actually the hash of the certificate that my email server is offering you if you try to send me an email. Here is more about Dane, where you can read. Why do the pictures don't work? Okay, so here it should be a picture of two mail servers. One is sending mail server, one is receiving mail server, and two DNS servers. So when I established the encrypted session, SMTP session, my server, that is sending server, receives the certificate hash. It gets offered a certificate from the other side. Now, I ask for TLSA. So I would ask for the TLSA of the other server, and if I get it through DNSSEC and through Dane, then I can match. So if both are the same, this means that the other side is actually who they claim to be, so I can send an email, right? This is just verification. Okay, more, okay. So, and when I set it up, I needed to test it, right? If it works. So we have here from T2, that's a provider, services provider in my country. They're usually following what I'm doing in the lab, and they are doing the same experiments on their network. So it's quite easy. Whatever I'm doing, I'm talking to them, and then I can test, we can test against each other. So I send them an email, and I saw that on my email server, you get this, verified TLS connection established. Verified means it was verified with Dane, okay? And then I said, okay, who else is using Dane? Of course, our friends from NLNet Labs. So I sent an email to Benno, and I sent immediately another one saying, when you reply, can you please have a look on your log files and see if the whole thing validated towards me. And you see that from their email server, it was also verified TLS connection to my server. So I said, hey, it works. So this is the Postfix config. that you need to add or modify if you want to use Dane. So it's not very hard. It's quite easy to do. And in this way, if you publish the TLSA, you are protecting your server, so people understand that you are you, and you're also verifying other servers if they decided to do TLSA. Okay, and now what? I was again bored in my lab. I set up Dane, right? And it works. It's easy. So I said, okay, am I alone on the internet doing this stuff? Or is anybody else using Dane to do this stuff? So I said, okay, where can I get the source of domain names? And I realized I can go and fetch the top 1 million Alexa domains. And I built a script. I'm not a programmer. I'm a networker. I'm a system administrator. So I used Bash. And it's a spaghetti incident of script. It's a complete spaghetti incident. But somehow I made it work. After 2 weeks, I went back to change something, and I did not understand what I was doing there. But it worked. So that script sent an email to each domain, and the email address was test-dnssec-dane. That's usually not an email address that exists, right? At each domain. After some tweaking, I got it right, and it sent all the stuff, and then I analyzed the logs from postfix. And yeah, we parsed the log files, and here are the results. So what would you expect? How many of 1 million SMTP sessions were encrypted of any kind? Any guesses?
Tiny amount.
Hmm?
Small.
Okay. Nearly 70% of all attempted SMTP sessions were encrypted with TLS. How cool is that? How cool is that? Our NSA friends are not very happy at this moment. Not very happy. Okay, the majority of TLS connections, 60%, were established with trusted certificate. Can you imagine? People paid money for the certificate for the email server. And 1,382 connections where remote mail server announced TLS capability failed with cannot start TLS handshake failure. That means these people will never get an email from me. And now they're complaining. Yeah?
So when you say this is TLS, this was not necessarily Dane, though. This was start
Just
TLS or something. So it was a TLS connection initiated somehow.
Yeah, or anonymous, or untrusted, or trusted, or of any kind. So there is no establishment of authenticity or something like this. It's just
Right.
just TLS.
Okay. Did you find results of how many had TLSA records?
Yeah, sure.
Or is that coming up?
Yeah,
Oh, okay.
Ben, you're
I'm
jumping
impatient.
ahead.
All right.
Yeah, you're impatient. Come on. All right. Here is your answer. So anonymous, this means just a key, actually, without signing. 109,000 untrusted, that means self-signed certificate, was 167, trusted 410, and verified 128. Yay! I'm not alone in the world. I'm not alone. There is other people that is using this. Previously, Dan said it's 1,000 plus mail servers out there. Now, probably it is. Back then, it was. And I probably did not find them all because they are not in top Alexa domains. So, yeah, verified 128. So this is getting better and better. And it's easy. Okay, so mail distribution. Google.com, they had 125,000 domains. Secure server, you see here, TLS state trusted. No TLS trusted, most trusted, OVH.net, Yandex.ru, things like this. And you have emailserve.com, Zoho Mail, Lollipop. These are big servers. But the problem is that none of these domains are DNS sec signed. That means no Dane for these people. This is uncool. This is really, really uncool. Okay, so then I did this, I put together the numbers, and then I got bored again. I was sitting there, rotating on my chair, thinking about, what can I do with this Dane? Okay, how can I push it so far that it breaks? Let's see what I need to do that Dane will break, right? So let's check the malformed TLSA record. If you put in the DNS, the TLSA record, and as a hash, you just change one character. That means the hash and the search certificate does not match anymore. What will it do? It just said, untrusted TLS connection established to mail bad, because I put the TLSA as mail bad. Server certificate not trusted, and it did just drop the connection. It did not deliver email, because it said, I don't know who you are, but you are not the one that you are claiming to be. So all good. This one worked. Then I started playing with signed and non-signed zones. So if a domain where MX record, and follow closely, because this is going to be a roller coaster. You will get lost pretty soon if you don't follow closely. If a domain where MX record resides is not DNSSEC signed, just MX record, right? For example, if you have MX record in your zone that is not signed, and you're pointing the MX record to the A or quad A record that is in go6.si zone that is signed, what happens? Or if TLSA record published in non-DNSSEC zone, so can't trust data in a TLSA, so no verification. What happened? So here is a case, an example. go6.lab.si zone is signed, so is mx.go6lab.si. So there is a TLSA for mx.go6lab.si, and domain sign.si is signed, and mx points to mx.go6lab.si, okay? Now domain not signed.si, these are just examples, they're not existing domains. I'm just using them as an example. Is not signed, and mx points to mx.go6lab.si. So I send an email to Jan@sign.si and Jan@notsign.si, and what happened? So when I send email to Jan@signed, it says verified. But when I send email to Jan@notsigned, it says anonymous TLS. So the Dane process, it received MX record that was not signed, it just dropped, just exit. I don't trust this. And this raised all my flags. This was sort of like, whoa, hang on. Despite the fact that you can verify the endpoint, because Dane is the endpoint verification, not the path verification, you are not verifying it. You actually deliberately decide not to verify the endpoint. Why? Okay, I understand that MX cannot be trusted. So that means, like, you are flying somewhere and you do not trust the pilot to say we need to go to New York. But at least when you come to New York, you can verify that you are in New York and not somewhere else, right? It's a sensible thing to do. So I had a long discussion with people that are implementing this at Postfix, and they actually fixed it. They implemented it. So now in the latest version, if you would do this, it would not say verified, but it would say trusted, because the endpoint is trusted. It's not verified, but it's trusted. Okay, that's their decision. Okay, so let's try to point the MX record from signed domain to the quad A record in non-signed domain and TLSA that is also not signed. This also didn't work, because this shouldn't work. This shouldn't work, because you cannot verify the TLSA record that is not signed. And actually, with the unbound, the recursor. When I asked the recursor for the TLSA record in a non-signed zone, it said that it doesn't exist, despite the fact that the TLSA was there. I had to put break DNSSEC clause into the configuration. So the resolver started giving me back the TLSA records from the zone. Otherwise, it said, no, it doesn't exist. It's so out of mind that you are asking for TLSA record in a non-signed zone that I will not give you anything. It's no there. Go away. So this is how wrong this is. Okay. So this was the improvement from Viktor Duchovny. He said that, as you see, this was on 6th, it was on 3rd January. So he was not celebrating New Year's Eve because of me bothering him with this stuff. And he implemented that when a host has, MX host has a secure DNS TLS record, even if the MX DNS record was obtained with insecure lookups. So now this thing works. And this is one of the cases where you see the testing in a lab and in a real world, how to bring back the feedback to the IETF, to protocol designers, and to implementers in our software. Because otherwise, if they don't know, if they don't hear from you what is wrong with the protocols, with the design, and with everything, then they will never be able to fix it. So please do these things and report back to software developers and to these people so they will make it better. All right. Then again, guess what? I got bored in my lab again. I said, okay. Dane works. So now let's see this. At this time we started supporting the Let's Encrypt initiative. We are also sponsoring them. That's why I have this cool T-shirt. And I said, okay, let's try and put the Let's Encrypt signed keys and cover them with Dane. So you have double security, right? And but the problem is that Let's Encrypt recommends using 211 and 311 records. That means that 211 is a certification of the hierarchy, and the 311 is the digest of your key. But the validity of Let's Encrypt certificate is 90 days, right? And by default, the underlying key is changed when you're renewing. That means that I would have to change all the TLSA records in my DNS zone. And you know, me being 20 years in this business and in operations, I'm lazy. By default. By default, the underlying key is changed. Yeah. So if you plan to publish 311 TLSA, it's a lot of work. And I don't want to do a lot of work, right? Especially if you have lots of domains. Using the 211 method leads to another issue, namely lack of DST root CAX3 certificate in a full chain file from the Let's Encrypt. And so we need to fetch the DST root certificate and add it to the. This is my spaghetti incident. This is I fetch it with links, the source. I fetch the root certificate. I do some grep and awk and sed magic, and then I add it to the full chain. It's quite easy. Okay. But at next certificate renew, by default, underlying key will change, and 311 TLSA record will become invalid. So labor-wise, so you have a --CSR option in Let's Encrypt Auto client. Now, these days is a certbot client and has the same stuff. So in directory examples, there is generate csr.sh, and this back then, when I was doing this, was sort of like undocumented feature. But nevertheless, I generated my key, and then if you run let's encrypt auth --csr.there, and if you renew with this option, then the underlying key will never change. Or I need to decide, okay, now I will change the underlying key, and I will do it manually with the human intervention, and then go and change all the TLSA records and add new ones and things like this. But at least it changes when I decide that it needs to change. So now we're using the same underlying key for automatic renewals. Of course, we add the DST root certificate to fullchain.pem every time we change every time we renew. So I'm publishing the 211 and 311 TLSA records. That means that it's verifying both the keys. Here it should be a nice picture of a Dane verification.e that Dan showed, and everything would be green. Okay, more reading. These are 2 blog posts where I documented the process and everything that I was doing. If you're interested in this stuff, go and read them. And send me feedback. You have my email. I'm more than happy to hear some feedback or some questions. If you have some ideas what to test next, send me an email and I will see what I can do. I have lots of stuff that can be used in my lab. And this brings me to my last slide without pictures. I'm feeling like in old days of terminals and Pine and all that. No pictures. Pictureless.
You described it so well.
Yeah. Okay.
Okay. All right,
Thank you very
Ian.
much.
Well, welcome back to the last session of today. So what I wanted to talk about, we've got again, pretty packed program covering IPv6 and with the IPv6 panel. But one thing I just wanted to talk about before we get into that is an initiative we have known as MANAs, and also Routing Resilience Manifesto. And this is something that we've been working on as part of our collaborative security work within ISOC. And I think it's probably just worth mentioning just to make you aware of this. So MANAs stands for Mutually Agreed Norms for Routing Security. And I would say here, if Megan is watching, I finally changed this slide to be correct, because I've been showing this slide incorrect for about the last 6 months. But finally, I have changed it. So it's Mutually Agreed Norms for Routing Security, or MANAs. And what this is about, so it's about the BGP protocol that's used for global routing. It's primarily based on trust. And there isn't really any validation of routing updates. So when routing updates are sent or received, a lot of that is, pretty much all of that is based on trust, and that whoever is sending that is who they say they are. But this, of course, can lead to prefixes being announced that actually don't belong to a network. In some cases, this can be deliberate impersonation. In other cases, it can simply be a mistake. Probably more often than not, it's a mistake, but the effect is often the same. You can also have route leaks, whereby routes that shouldn't be globally advertised are appearing in the routing table. This can lead to other issues, such as traffic being intercepted when this happens. Then you can have source IP address spoofing, and we had This was mentioned earlier today in one of the presentations, which aids reflection DDoS attacks, for example. But then, coming back to the most simple thing, often network operators are just not very contactable. So when there are problems, if there is a DDoS attack, how do you get in touch with another network operator to tell them there's a problem or to ask them to take measures to mitigate that problem? So the aim of Manners is to build this community of security-minded operators with the aim of promoting collective responsibility. And the aim is to do this through 4 concrete actions. So we have the 4 concrete actions of good manners. First one is filtering, so preventing propagation of incorrect routing information through the definition of clear policies. Also implementing systems within networks to ensure correct announcements are made, and also customers of that network are also making correct announcements. You have anti-spoofing, so filtering to prevent traffic with incorrect source IP addresses leaving the network. Then coming back to the issue of contactability, coordination, improving global operational coordination. So in other words, maintain globally accessible, up-to-date contact information. And then finally, we have this sort of catch-all global validation. Primarily at the moment, this is referring to things like RPKI. I think that was mentioned earlier today. And also the Internet Routing Registry. So actually doing things like cryptographically assuring that a route origin or IP prefix is coming from the network that it says that it should be coming from. So if you're interested in participating, what we are asking is to sign up to at least 2 of these concrete actions. These are listed, more information on the website. But the Manners Manifesto, it's not just a document, it's also a commitment. The aim is it to be these are actions that you take when you agree to sign up to this manifesto. So one of the things is you need to support at least one of these actions. I think I said 2 earlier, actually, didn't I? But it's actually 1. You need to support one of these actions. But the idea is really to try to sign up to as many of these as possible. I don't know. I think we're having slightly jinxed slides at the moment. They're changing by themselves. But anyway, but just to help you with this, we're actually producing a Manners BCOP document at the moment. This is in production. My colleague Andrzej Robczewski, Sander Stefan, who has a lot of experience in this field, and I'm also contributing as well. We're working on this document. This will be published hopefully before the RIPE meeting next week. And this actually lists in much more detail what you need to do to take each of these steps. This is again another one of these bottom-up, community-maintained initiatives. If you sign up to become a participant in Manners, you can contribute to helping improve and maintain the operational practices. You can suggest new actions. You can help maintain the existing store of knowledge that we have. So if you're interested, as I say, go to the Routing Manifesto website, the Manners website, for more information. My colleague Andrzej would be pleased to hear from you, and he can put you in touch with, or provide you with the more information that if you need that. So that's my piece on that. I don't know if there's any questions. If not, I'd like to move to the next talk. So it's making the case for IPv6. I'd like to invite Alvaro Vives from the RIPE NCC to provide the first part of the IPv6 case. Then we'll move to the panel after that.
So, hello to all. I will start talking about IPv6, and we later have a panel on the issue, so we can also answer some questions. And probably there are many questions about this issue, IPv4 and IPv6. But the main idea for my presentation today is to give you some update on why IPv6 is happening and how is it happening today. Because my main idea is that it's something that is happening today, something real. And we will see, even there are different speeds for IPv6 in different countries and regions, we will see that all the statistics show a very high increase in the numbers of traffic, of customers, and even prefixes, and all these things. So first, I'm working for RIPE NCC right now, so I will explain shortly what do we do in RIPE NCC. We are the RIR for the Europe, Middle East, and Central Asia region. So we basically manage internet numeric resources, let's say AS numbers and IP addresses, both IPv4 and IPv6. In addition to that, we also keep a database, RIPE database with all information related with these resources, contact information, and even a routing registry associated with the prefixes. We are independent, not for profit, and we are membership based. So we have members that pay an annual fee, and that's the money we have to do all our things. We try to keep neutral, transparent, open, etc. Okay. We have 5 RIRs around the world. We receive resources, numeric resources from IANA. It's the one that manages the numeric resources and allocate resources to the different RIRs. We have ARIN, LACNIC, AFRINIC, and APNIC as well, in addition to RIPE NCC. So the first idea, shortly, is the why IPv6. I mean, a lot of people are really reluctant of a new protocol. Why are they changing this protocol that I already know about? I'm confident everything is working. Okay, so there is it's a little bit curious that in our world, technology world, is one that things change quite fast. 10 years ago, we didn't imagine what's happening today. But with IPv6, something that people keep trying not to go for that. Something people try to keep on IPv4. Something different than in other technologies. So why IPv6? We can say that the first main reason was the IPv4 address exhaustion. This is something that came beginning the 90s. There are already some concerns about exhaustion of IPv4 addresses because at the beginning of the internet, the addresses were managed not very efficiently. They were handled out in different classes. You know about class A, B, and C. And if they still do that, the addresses will have exhausted in 94, it was expected to be. Then 2 things happened in that moment. One is that a new protocol was standardized, the basics of IPv6, and the other things was a well-known NAT and private addresses and the CIDR way of dividing in any length of the prefixes. So that made the IPv4 long much more time, and still today is the most used protocol. That's true. But we are going to see that the addresses are exhausting for real, and even some people say there are still a lot of unused addresses. Right now, it's not happening. I mean, there are some reserve addresses, there are some addresses out there not used, but today, if you want to get an address, you will have to do a hard job to get that. The other thing that has pushed the IPv6 in deployment and make things happening today is the number of connected devices. The number is growing exponentially. It's something that's growing year by year. And there are no doubts that there will be tens of billions of devices connected in the following years. So all this Internet of Things hype, and nobody's sure what's that about, but what's for sure is that there are even more and more devices connected. Many people talk about the number of population and people, but we have to start thinking on not just people, but devices connected. There are many things that are getting connected to the Internet. So number of devices is rising quite a lot, and you need addresses. Even using NAT, you need public addresses to connect that devices to the Internet. So that number is so huge that even using NAT and PAT, let's say we're using transport protocol ports, you still need thousands of addresses to connect them. The other thing that has improved during these years, was the IPv6 protocol itself. At the beginning, we had some basic definitions, some basic standards, but things have been improved. With experience, they have developed good practices, and things have been refined and getting better with time. It's been a long time, since 1998, when the RFC was defined, but there are several protocols associated with IPv6, and today we are going to see that things must be working, because we can see there are millions of users out there using even IPv6 only for connecting to the Internet today. So all these three things has converged in what we have today, and we can say that IPv6 is happening now. Okay? Let's see then, how is it happening? And this is something that is not easy to measure, because we are going to see that it's happening at different speeds. We are going to see there are many differences between, for example, fixed and mobile operators. Mobile operators are moving quite fast, are the most growing networks. They have millions of users, and even there are several millions of devices connected. You know, lifts, carts, and electricity meters, many millions of things connected using mobile networks. Also, depending on the region or even on the country where you are, we are going to see there are different levels of deployment of IPv6. Depends also on the type of network or the business. It's not the same an ISP than a content provider, than a public organization. Each of those has different motivations to implement IPv6, and they have different internal specifics that make it happen or not. Also, we have seen in the past the vendors, both hardware and software, has implemented all the IPv6 in a different speed. But today, in general, we can see there are most of the products has a good support of IPv6 in its main good percentage of their features. Also, we are going to see some measurements, but I left at the end of the presentation some links so you can investigate further, because you can measure different things. For example, from RIPE NCC point of view, we are going to see some details about the addresses, IPv6 addresses handled out in our region, and if they are announced in the BGP. We are going to see really nice statistics and good numbers, but what that means is that in the infrastructure level, things seems to be very good. But if we go to the end user statistics, we are going to see there is a gap on that. So it's something to take into account as well. For example, you can measure the DNS and availability of the services that are announced over DNS. That means that the domain names, when you resolve a domain name, you get IPv4, IPv6, or both addresses as a point of contact to that service. So when you want to make public your IPv6 available service, what you have to do in the last step is to publish on DNS. What people doing right now is to publish on dual stack, both IPv4 and IPv6. So you can measure the DNS resolution of the most used domain names and try to see how many of those are available over IPv6. Also, there are some statistics about traffic, about packets happening on different networks, internet exchange, different network or content provider. We have several statistics for content provided networks, like we have Google, we have Akamai, that show how many connections they receive on their services over IPv6. That's quite interesting as well. And also there are some measurements, quite interesting to see what percentage of the clients are capable of connecting using IPv6 to a service. So depending on what you measure, you will see different levels, but I would like to make it clear that what we're going to see are the trends on the statistics, and they are all growing, okay, most of them. So it's interesting to monitor values in time, so to see what's happening, how things are moving, because in my opinion, I think that IPv6 is like, you can see like a snowball that is started to roll down the hill and is getting bigger and faster, something that's going to speed up in the near future. You can also compare with IPv4. You can also try to measure how good it performs compared with IPv4. It's also interesting to see the delay, the number of hops, how things are happening comparing IPv6 and IPv4. Also, we are going to see some statistics, and you can correlate the different values on the statistics in time with a specific events that has happened in the past. We have, for example, the biggest one in 2011 was the IANA IPv4 pole exhaustion. So IANA run out of IPv4 addresses. It was a big news and was announced in several newspapers, and a lot of people realized about this is a real problem out there. Also, we have the different RIRs have been reaching their last /8 or last resources, IPv4 resources. What made the policy they have to provide, to give IPv4 addresses to their members more restrictive. It's not that easy now to get IPv4 addresses. And also two interesting initiatives were the World IPv6 Day and the World IPv6 Launch, organized by the ISOC, where in the first one, it was 24 hours of huge content providers enabling their services over dual stack, so they are available over IPv4 and IPv6. And the World IPv6 Launch made them enable, until today, dual stack services available for everybody. So let's go from globally into our country, into Romania. So let's start globally. We can see the growth is pretty high. For example, Google measures the percentage of people connected to their services. Google has all their search engine, Google Docs, YouTube belongs to Google. They have huge amount of services that are quite used by people out there, and they have already reached over 14% of their traffic over IPv6, native IPv6. The fluctuation, somebody said here that this means that the service is having problems. That's not true. The fluctuations you see on the details, you see that the traffic follows a holiday pattern, let's say. You can see that people on the weekends access more Google services over IPv6. You can see, for example, on holidays, around Christmas, you have a sustained access to the services. So it follows, let's say, end user pattern. If people accessing the IPv6 are end users. You see in some other graphs, you can see with lower levels, you can see the opposite. There are some patterns where you see the people access over IPv6 during the weeks. So they are using their company's connection to access IPv6 services. We can see also from Epnic Labs the amount worldwide of IPv6 capable hosts connecting to services. It's over 6%, almost 6.5%. And they also show you of those IPv6 capable ones, which ones prefer IPv6 over IPv4 that are almost the same. From RIPE NCC point of view, you can see the number of announced IPv6 prefixes, and we can see there is a big growth, and we can see also a correlation between events. We can see that around 2011 there was a huge growth, and also in 2015 that could be because of the ARIN exhaustion. ARIN right now has 0 IPv4 addresses on its pool. So it's something that was really a good news for IPv6, let's say, right? But if we go into a region or per country, we can see that things are quite different between regions or countries. For example, Google showed you how much, you don't see it quite better, but green is good, and the darker is green is much better, the amount of traffic, and red is worse. And also, if it's going red, means that the performance of IPv6 is not very good. So in general, we have IPv6 performing a little bit better or similar than IPv4, and we see that different countries has different values. APNIC has also measurements about the IPv4 and IPv6. You can see huge difference between regions and countries, and also some values. We can see that for the whole world, the IPv6 capable host is around 6.5%, but there's a huge difference between, for example, Americas, that's all North and South and Central America, and, for example, Africa. Okay, there are huge differences on the IPv6, on the statistics they have. Also, between countries in our region, we can see that there are different values. Something interesting, if we go into the 5 best countries, we can see, for example, Belgium is doing quite well with almost half of the traffic accessing Google going over IPv6 for a whole country. That's quite good. It's a small country, I know, but it's not bad. And what's also interesting is that we have in the first 5, we have Greece and Portugal. We know that Portugal and Greece are not doing well with all the crises and economies are not quite good, but they still are pretty high on these statistics. That means that doing IPv6 is not a matter of money, but it's just a matter of wanting to do things and implement IPv6. Romania is doing quite well, is in between the best in our region with a 6.4%. This is measured by Google. That means Google has a service and they measure how percentage of connections coming from Romania came over IPv6. So it's not bad, and there are many countries, like I'm coming from Spain, we are really ashamed. We have 0.01%, something like that, so not doing well. But in Europe, we can see there is a constant growth, linear constant growth, and that's the trend. Okay, that's something that's happening. And we can also differentiate between the different areas, regions inside Europe. Okay, it's not the same Western Europe than Eastern Europe or Southern Europe. It's different values you can measure there. From RIPE NCC point of view, the members of RIPE NCC, the LIRs, the local internet registries, receive resources from RIPE NCC. We allocate resources to them. So right now we have 40,500, a little bit more LIRs members, and I'm going to show you the numbers of IPv6 addresses we have handled out. You have 3 categories here. You have, in green, there are the LIRs that doesn't have any IPv6 address, so they have not requested as IPv6 addresses. We have in yellow LIRs that has received allocation from us, has received IPv6 addresses, but have not announced it. They just received it, but didn't do anything with them. And you also have the LIR that has IPv6 addresses, and they are announcing on BGP. So they are announcing the rest of the internet, I have IPv6 and send to me this traffic. From our point of view, this is what we want to see. All LIRs has IPv6 and announcing the BGP because that probably means they are using on internal services and for their customers. The number has been growing quite constantly. We can see a little bit speed up when around 2011, when the IPv4 poll exhaustion in IANA and the World IPv6 Day, but then has been growing quite steady. The LIRs with IPv6 but no BGP means they have received. We did our job. We convinced them, okay, you have to get IPv6, but they are still not announced it on the BGPs. We can see a couple of speed ups here. One was around 2011 as well, and the other one was after the last /8, when RIPE NCC reached the last /8, people started to be concerned about not having IPv4 addresses because the policy made it much more difficult to get IPv4 addresses. In fact, you only can get once a /22, the last one, just one time. So everybody starts to get IPv4 and IPv6, and the number of IPv6 allocations grow quite fast. And last, we have the LARs with no IPv6. They have not received IPv6 address. That's not good. And we can see that around the last /8 was reached by RIPE NCC, the number of LARs with no IPv6 go down. But then something happened in March 2015 that a new policy was put in place. The policy 2014-04 that removed the requirement to have IPv6 to receive IPv4 addresses from the last /8. So they can decide if I want IPv4 or not, and many people decided, okay, I don't mind about IPv6. Okay, and you see how the number rises. We at RIPE NCC try to work for the good of the internet, and one measurement we do is the IPv6 ripeness that measure our LARs. So they receive stars depending on how they have moved forward with IPv6. The first step will be to receive an address. So receive, a prefix, a location of addresses, and they got the first star. And then they can get 3 more stars, depending on if they do one of these 3 things. One is to announce the prefix, so we can show it on the routing system. The other one is they have registered the prefix on the routing registry. In the RIPE database, there are some objects called route 6. And also have configured the reverse DNS for that prefix. So we have here the numbers. You can check it on that URL. We have 21% of 4 stars, so they have all these things already done. That's quite good. And we have, in the other side, with no IPv6 at all, so 0 stars, we have 24%. And we have then a range of LARs between 1, 2, and 3 stars. Okay. Also, we have created a new 5th star that's kind of, you have to be really proud of that, for both content networks and access networks. Depending on the real use of IPv6, you get the 5th star. That means that you are really using it. And we use a threshold to measure if you deserve the 5th star. If you are a content network, you have to qualify having IPv6 enabled sites, websites, taken from the Alexa first million of most used websites. Or if you are an access network, what's measured is the number or percentage of IPv6 enabled users you have in your network. So how many customers do you have that are using IPv6 from your network? So let's go even with more details about Eastern Europe and Romania. We can see that there are big differences between countries, and we can see that Romania is doing well, is in the 2nd place. This is measured from APNIC Labs. So that means that the percentage of IPv6 capable hosts, okay? And almost the same values you have for IPv6 preferred. So it's not doing bad, but I think it's still a lot of things to do. If we look into RIPE NCC statistics of these different countries, we can see of the number of LARs of each country, how many of them are already announcing the IPv6 prefix they have received, or they only have the prefix but don't announce it on the BGP, or doesn't have IPv6 at all. More or less, they are looking the same in percentage, but we can see some specific things to take into account. For example, Poland is doing better than the other ones, with almost 47% of their prefixes being announced on the BGP. That's quite good, almost half of the prefixes. There are also Belarus and Czech Republic that has a 55 and 59% of LARs that has IPv6 addresses but are not announcing. They are not using that addresses. That's not good. And which way around, sorry? Oh, you're right. Yes, you're right. I made a mistake because this changes the colors on the other graphs I had. You're right. So Poland is doing bad. Sorry, if any Polish in the room. They have almost 47% of having IPv6 but not announcing it. And okay, and then Czech Republic, that was, yeah, and Belarus, IPv6, and they are announcing it on BGP. That's quite good, nice to see. And no IPv6 at all is Moldova, that has 41% of LARs, members of RIPE-NCC, that doesn't requested any IPv6 address. That's not good. Yeah, that's a good question. I have that graph. I can send it to you or show it to you, but because the different countries are many different number of LARs. Yes, Russian Federation has 1,300 and Romania has 120 around that. But in percentage shows a little bit what the country doing. But yes, the numbers of LARs are quite different between countries. So if we go to Romania, we can see that there are 38 LARs, 32% already have 4 stars by ripeness. We have 20 with no IPv6 at all, and then we have some of them with 1, 2, and 3 stars. You have there the numbers. And we can see that how was the trend on the numbers over time, and we can see there is a similar pattern than we have seen for the whole region, for the whole numbers of LARs in RIPE-NCC. We can see that all the graphs are growing. We have some 1 year or more than a year where the number of prefixes announced didn't grow, but now it's still growing. We can see also how the number of LAR with IPv6 but with not announced it in BGP is also growing quite fast, like in the rest of the region. And also we see the same pattern of growing of number in LARs that doesn't have IPv6 at all, similar to the whole region. So after seeing this, the main idea is that IPv6 is happening from RIPE-NCC. There are the number of LARs is increasing quite a lot, and the number of those LARs that are receiving resources, IPv6 prefixes, is growing also quite fast. And all the statistics about measurements, depending on what you measure, but all of them show a growing trend. So you have to decide what to do. Because sometimes even changing one ISP in a country changes the statistics for the whole country. We are going to see a couple of examples quite interesting. One is in the Netherlands, where Access for All already implemented IPv6 in August 2010. This is measurements made by Akamai. So Akamai is a content delivery network, and they measure how people are accessing their services. So they measure, we can see at the beginning, the main traffic are coming from Access for All clients. And then in June 2015, KPN deployed IPv6 in their network. And even if they only had 6.7%, you see how the growth in the whole country statistics. And then in February 2016, Ziggo implemented as well IPv6 for the clients, and we can see a growth on the country statistics. So even if this, also there's something interesting here is that you can see that ISPs implement IPv6, deploy internally, but not for the 100% of their customers. Probably they have the new ones, or if you have different access networks, you have mobile, you have a DSL, you have fiber, then you start doing in different phases for different kind of users. But we still see how the traffic grows. Another interesting example is United Kingdom that was doing really bad until Sky started to implement IPv6 for their customers. And we can see how the Sky statistics follow the same pattern as the country. And today, United Kingdom, in just some months, has reached more than 11% of their traffic seen by Akamai. This is always keep in mind that this is something measured by Akamai, but we can say that is quite relevant, the growth in the traffic. So we have seen what's happening out there, and you have to decide what you do. It's something that is just you have to decide in your ISP, in your LAR, your company, your organization, and we can roughly say you can be in 3 positions. You can go behind the average, so you just wait, do nothing, and wait to see what the others are doing, or when things get more mature, or to see what's happening out there. Okay? The 3 positions we are going to see have pros and cons, but this one, I mean, doesn't cost anything. You don't have to do anything, but there are several risks of keeping where you are, not moving. Okay, you have somehow to move forward to keep where you are. You for example, can get behind your competency. If your competitors are offering their services over IPv6 and you are not doing that, maybe some customers go to the other ones. I mean, there are several risks. We don't have many time. Maybe in the panel we can go deeper. You can go in the average, depending on where is your scope of visibility, but you can do like in the world, 6.5%, or Europe, or your own country. The thing is that you want to be visible out there to follow what the others are doing. Or you can go ahead of the average. You can be an early adopter. You can be doing things with more time, with lowest pace, and getting the know-how about the technology. And you will probably have to do some debugging and some work, but today is not something that's getting so hard. Today we have many of these early adopters out there. We have ISPs, we have content delivery networks that have been offering IPv6, even IPv6 only networks where the customers have only IPv6 and want to connect to the services out there. So one important idea I would like to say is that if you want to be visible to the whole internet today, you have to be visible over the 2 protocols. Because if you are only IPv4 and you keep doing nothing, there are IPv6 only networks out there that if they try to connect to your services, they probably have problems. Not everything is going to work for sure. Okay. So in summary, IPv6 adoption is happening all around the world. I've seen that. But depending on the measurements and the country and the region, we see different values. But the trend is something that I would like to stress is growing in any place. And you have to decide what to do about that. If you want to be visible out there and you want to be ahead or on the average or behind what's happening out there. And also, IPv6 is important. That's for sure. It's the only solution, the long-term solution we have for the internet, for our communications. And if you do things in time, it will still be important and not get to be something urgent. Because if you do it urgent, you will go faster and probably will have more problems, more failures, and it's not something recommended to rush to implement a new technology in your network. I left here some references. Also, just shortly do some advertisement about the RIPE NCC Academy. It's a free resource you have out there in the academy.ripe.net. We right now have 3 online free courses. You need to create an access account at access.ripe.net. We have a basic IPv6, LAR course, and a database. And we are working on creating new ones probably next year. So keep that link in mind and check if there are new resources for you.
Okay, thank you.
We're getting a bit pushed for time. I will take some questions if there are any, but before I do, could I ask Lucian and the panelists to come up and assemble themselves while we're taking a couple of quick questions maybe, and that will save a bit of time. Yeah, 4 people, yeah. Sorry, there was a question just there. Yeah. Sorry, could you use a microphone? There's just one behind, I think.
I just wanted to ask you, where is the graph for Romania, for IPv6 in Romania, from Akamai? Why didn't you include it in the slides?
I didn't go into details of traffic in the country. I just showed.
Because I think it would have been very interesting. You can see that Romania went down.
Yeah.
There are some reasons behind that.
Okay, yes, you're right. Traffic measured from Akamai, the number of clients coming from Romania is going down. But, yeah.
Were there any more questions for this talk? People want to save them for the panel, perhaps. Okay. Your seat is there. So I will introduce the panel. So this is an IPv6 panel on IPv6 success stories. It will be moderated by Lucian Constantine, who is from IDG News Media. He's kindly agreed to do this for us, and we thank him for that. I'll ask the panelists actually, or Lucian, maybe you want to ask the panelists to introduce themselves, because we've had a couple of changes since, as announced on the program. But with that, I'll hand over to you.
Should I introduce them myself? Or
if you can, yeah. Yeah, thank you.
So, hi everyone. My name is Lucian Constantin. I'm a news correspondent with the IDG News Service. It's a news wire for technology publications such as Network World, Computer World, PC World. So we are here for the IPv6 deployment panel. I know it's kind of late in the day, so to make it more interesting, I'm going to allow questions as we go along from the audience. So if you have any question or comment to make to one of the answers, please raise your hand and we'll try to get a mic to you. I won't be able to take too many questions though, because we are short on time. I'd like to introduce the panel. I'll start over there. You know Alvaro Vives. He's a trainer with RIPE NCC. Sorry. We have Adrian Mintza. Adrian Mintza. He's a senior system engineer with the Romanian Special Telecommunication Service, which, among other things, acts as an ISP for public institutions in Romania and handles the governmental infrastructure. We have Jan George. He is Operational Engagement Program Manager for the Internet Society. And we have Claudiu Foleanu, who's Chief Technology Officer for Tenet Telecom, which is a local ISP. Thank you all for agreeing to take part in this panel. To go ahead, we've had an earlier talk, controversial talk, with arguments on why IPv6 is allegedly a failure in some sense. One of the arguments brought up was that IPv6 has poorer performance than IPv4. And is that a legitimate argument? Should people be concerned about this? And maybe Alvaro can share some info on that. Does it work?
Where's the button?
Tell you what, I'll give you...
Okay, yeah. Yes. Okay, thank you. Yeah, the measurements out there shows that, yes, the same as we have seen in the presentation, there are differences between countries and different around the world. And what we can see now is that IPv6 in many places is doing worse than IPv4, but in some places doing better than an IPv4. So, and they are improving. So it's something that we still need to improve that, but you can't be, you don't have to be concerned about that. It's not something that should refrain you from implementing IPv6. It's not even, we are talking about milliseconds of difference. So it's something that the user experience won't suffer too much. Maybe if you are in a couple of countries where you see 200 milliseconds of delay, but it's something that not even human can realize about that. And we also have a mechanism like happy eyeballs that make it flexible, preferring IPv4 and IPv6. So the end user experience in many cases is not bad. So I won't say this is something that is a problem right now.
Okay, Thank you. Jan wants to add something.
Yeah, so I have this one. I got used to it in the morning session. So there was the measurement from Facebook, and to their surprise, they started measuring between 15 and 30% better user experience over IPv6. They still have no exact explanation why this is happening, but this is what they measure. So at the last IPv6 summit in Slovenia, we then invited a lady from LinkedIn, because they did the same experiment, and they are measuring between 20 and 40% better experience over IPv6 than on IPv4. And they also don't have, because when I took them for the tour of Slovenia, I was in the same car, and I had a long discussion with her why this is happening. She said, we don't know. Nobody knows. But it's constantly between 20 and 40% better experience. And here is, so, but my take is that we don't have to compare these two things before we equalize the policy, our peering policy. So if you're an operator, please take into consideration, if you deploy IPv6 and if you start doing peering over IPv6 and you implement it for their users, equalize the IPv4 and IPv6 peering policy. So if you're peering with somebody on IPv4, peer also on IPv6. And when we have the same peering policy everywhere, then we can start comparing how the protocols behave, right?
Does anyone have a question? Yeah, sure.
I can provide a short answer for the difference in speed from the problem you talked about. There's actually a better speed on IPv6 due to the fact that the upstream providers offers more bandwidth in order to support implementation of IPv6. For example, someone like Hurricane Electric can actually provide you something like 40% of the routes in the world for IPv6 and doesn't charge anything for it. So that's why the bandwidth is it's higher. And free IPv6 transit, yeah. So that's why the bandwidth is higher.
No, same servers.
So they use this exactly same servers, is just the difference of the protocol. Okay, but you've been at all the right presentations and all the measurements showed technically that IPv6 is performing worse than IPv4. So it doesn't have a logical explanation.
Well, we are not talking about the protocol itself, because Jeff Houston and his people were just using pings, right, to measure stuff.
Not only pings, also the add service, which is measuring actual connections. So he had a presentation in which he showed that the TCP connections are worse in IPv6.
Actually, introduced
you know it.
Jeff to the stage.
So you remember it. Then you know that he showed clearly from his measurements that TCP connections have a larger drop rate than over IPv6. So there is no technical reasons for IPv6 delivery to work better than IPv4.
But this is the measurement of the real content. The content that people is actually seeing. People, regular people don't use pings and trace routes for the internet.
Yeah. They use TCP connections. But maybe if, as Claudio was saying, if there is a different bandwidth used, then it's just a temporary impression. Having a better experience is just something temporary. When the traffic will be the same, it shouldn't be the same.
Didn't you say that you sold all the IPv4 addresses that you could, right?
Yeah, from Romania. Yeah.
What's in it for you?
Nothing.
Just to clarify what Jan said about user experience, are you talking about latency or some different metric of user experience?
It is, they basically did the test of how the content loads, what are the times, actually the user experience. They were measuring the user experience, the whole thing.
Time to interaction or something like that.
Yeah, basically.
Okay. So I guess the conclusion to this question is if you want, you can deploy it and test it yourself. Moving on, another issue raised was the cost of replacing existing CPEs, that's customer premises equipment, and possibly other infrastructure changes being more costly than actually buying IPv4 addresses. Myself being a reporter focused on the security industry, I know that a few years ago there were concerns in the security industry about security devices like firewalls, IPS, IDS, not playing well with IPv6. And since Jan has a lot of experience assisting and advising ISPs on IPv6 deployment, I'd like him to address these concerns.
Oh, firewalls, okay, yeah.
CPEs, replacing CPEs.
I was thinking about something else. All right, years ago, if we talk about the equipment, the speed bump to deploy IPv6 was the equipment, the implementation in network equipment. So actually what happened was, to make the long story short, I was asking the people from our government, we met over beer somewhere, and I asked them, why are you not requiring IPv6 when you're buying equipment in your tenders? And they said, because we don't know how to. We don't know how to put the specification in. We would, but can you please write us a small text that we will put in? And I said, okay, challenge accepted. We drank another few beers and I went home, right? So then I started writing this stuff and thinking about it, and actually it came out, Sander Stefan joined and Mary Kekia at the end, and now we have the RIPE 554. I don't know, how many of you have ever heard about the RIPE 554 document? Okay, the usual suspects. This is the IPv6 requirements for ICT equipment that is divided into 4 different parts now it's 6 different parts for several different equipment. And there is a mandatory requirement where the RFCs and the specifications are that this equipment must support. And there is the optional part where if some people that sends in an offer for the equipment for the tender can have more points when the tender is evaluated. And this actually became the norm around the world for the IPv6 requirements at the vendors. Basically, Cisco told me that our document was the basis for their roadmap for IPv6 in Cisco. So it is translated in 17 languages now, or 18, I hear. Maybe you should translate it in Romanian also and let people use it, because it's just a template. And actually, this document pushed vendors into deploying more and more, not just mandatory IPv6 RFCs and requirements, but also optional ones, because this is how they win tenders then. This is how they get money. So there is an incentive to implement this stuff. So we have seen in last 2 years, we have seen a big uptake in compliancy and IPv6 capabilities in hardware. So if you are buying hardware today, make sure you use RIPE 554 and require IPv6, because if you're buying today the equipment that doesn't support IPv6, there's something wrong with you.
I have a question. Do you have any influence in Brussels? Because I'm seeing a lot of public projects financed by the Brussels, and they didn't specify anything about IPv6. Brussels.
Oh, Brussels.
No.
European
Yes.
Union,
European.
We can try. We can always try. Right.
If you want to push IPv6, at least you could change the policy for new projects for financing.
When we finished the RIPE 554, there came the German government, and they did their own specification based on RIPE 554, but it's a little bit more detailed. And both these documents went into as an input for European IPv6 profile that will be, I think, soon pushed to all European member states.
and will be required if you're buying equipment. You need to use this.
Not only for equipment, for the whole project.
Okay, yeah, maybe. Well,
Right now, I don't see any project that asks us for IPv6
yeah,
space.
it's a pity. We need to raise some awareness in there also.
And they are multi-million projects,
Yeah.
and with public sites and.
Well, in Slovenia, we had several projects that, for example, they were giving out some money for some mobile applications and things like this. And the first and hard requirement was it must work on IPv6 only network, period, full
From
stop.
the Polish government?
No, from Slovenian government.
From Slovenia, okay.
Yeah.
Just a few comments. If you manage to somehow get the document side by China, maybe we'll deploy IPv6 faster. Something like 90% of the hardware coming out of China, it's IPv6, without IPv6. So that's the main issue. The difference between an equipment for a client with IPv6 and IPv4, it's something like 40 euros. Just for the software. I mean, the device is quite capable of doing that, but you can't manage to modify the software in order to use IPv6. So that's the main issue why IPv6 doesn't get implemented faster almost everywhere. Yeah. It's good that the European companies are addressing the issue and using your document as a reference in order to implement like Cisco, but I can also tell you that Cisco has routers, old routers like Cisco 4948, the 10 gigabit model that doesn't do IPv6 hardware. It does it software.
Yep.
And you have to continually update your equipment in order to support IPv6.
Can I clarify something? So I think Jan was meaning that you are the buyer, so yeah. you can put this as a requirement. Do you want to sell me stuff, gear, equipment? Yeah, but you have to support it. Unless I'll buy from somewhere else. I know there's probably a price consideration here, like a business impact. Chinese equipment is probably cheaper.
Why you mentioned China. Actually, we are very near. The other day I got an email from Taiwan government saying that they're using RIPE 554 for their specifications. So yeah, we're getting there.
Good, great.
If there are no questions from the audience or comments, I'll go into the next. This brings us to into the next question, and well, actually, it would be good to hear from ISPs, from the people who actually implemented IPv6 or are in the process of doing so, and hear what were some of the most major challenges they've encountered or what benefits they've seen after they deployed IPv6. And I'd like to start with the STS.
We started deploying IPv6 in around 2012. Just after the main ISP in Romania deployed for his customer IPv6 band, because we are providing information to the public, we decided to open IPv6 also to our servers and to our networks. Unfortunately, our customers, which are public institutions, didn't adopt until now IPv6 in their networks. They keep coming for IPv4 to us. We are LIR, but from our standpoint of view, we see two main speed bumps or two main obstacles. The first obstacle is the subjective one, which is linked to the level of knowledge, expertise knowledge, and this is the harder one. And the second, on their part. And the second problem is the problems with hardware, network hardware, and this is the objective one. We have seen equipment crashes from all the vendors, almost all vendors we have, and we have seen equipment crashes, firewalls, routers, big unfortunately, right now, waiting waiting and not deploying IPv6 is a better choice than deploying IPv6 and encountering all sorts of nasty issues with hardware vendors. So these are the two main blocks in IPv6 deployment from our standpoint of view.
Well, if I can comment on the expertise part, maybe the government can consider something like they did with GovIT Hub, where they've asked for volunteers to help them create new IT projects to digitize the whole government systems. Maybe they can ask for volunteers with network knowledge to help them deploy IPv6.
Unfortunately, right now, if you check, the Gov site is not available over IPv6. From my standpoint of view, it's a work in progress. We have to convince the guys over there that they need IPv6. And right now, we didn't have many success with doing that. So maybe they will after this conference, or maybe after somebody from European Union will require in their documents for public sites to be available over IPv6 and public institution to offer their information over IPv6 as well.
So they need a stick.
Yes. And a carrot.
And a carrot, yeah, and a carrot.
Yes. Why should you implement IPv6? Let's talk about that. Well, I did it for a simple reason. I needed to see what were the problems. And I added an IPv6 address. First of all, I have to subnet the /48 I got from RIPE or something like that. I managed to do that with a subnet calculator, and I got something like 65,000 addresses to be added on my router. And I looked at it and said, oh my God, there's more than I have on IPv4. Should I waste them? And then I looked what RIPE allocated to me, and it was something like 1,200 billion IP addresses. And then I added the addresses on the router and started to configure my servers. I encountered that most of them already being on the same private LAN, they already got addresses. I found out about auto-configuration. Everybody was having an IPv6 IP address. Just by adding them on the interface, every router in the same VLAN got an IPv6 address, and now I had a new problem. I had no firewall. I had a firewall on IPv4, but no firewall on IPv6. And I started to testing how can I disable services like SSH, like Telnet, like web over IPv6 so they can respond only to IPv4. After that, I settled that I must learn more about IP tables, about firewalling on Cisco in order to drop connections over IPv6. I managed to do all that. I added IPv6 addresses to every server, to my web page. I done reverse DNS. I've done everything in order to see the potential. I found out that you can mail better with IPv6, that the speed is actually better, not like everybody's saying that the latency is greater. I haven't seen that. But you have to do that in order to be sure that when it's deployed fully, you will be a step ahead. Because I had a customer that requested an IPv6, and I allocated him addresses, and they next called to the support center and said, my TV is actually not working. And I said, how? And we have new dots, line appearing on the TV. And I said, okay, what's the problem? I'm not from the cable company or not from the... And I said, I connected it to the internet. One of the operators from us went to the customer, tested the signal, tested everything. We said maybe there's power over the Ethernet cable or something like that. No, actually the TV got an IPv6 address and was vulnerable via IPv6. And the guys went into the TV and started changing settings and stuff like that. So we disconnected the TV directly from the network and put it into a router to get only IPv4. The next call from the same customer came that my lights are going down, my heat station is going up, my doors are unlocking. He connected the smart center from the home directly onto the network and got an IPv6. And the guy from the smart center said, look here, you forgot to put a password for IPv6. So that's the main reason why you should implement IPv6, in order to find out the bugs, to solve them ahead of time, and to be ready for the revolution. So nobody hacks you when you really need IPv6.
It's quite important to learn all these things in advance before deploying it in real life, because for example, the mobile network in my country. So we deployed in Slovenia. We have IPv6 on all three major mobile operators, and also our telecom is giving out the IPv6 by default. But when these people, mobile operator, when they enabled IPv6, and they enabled for every phone that can do IPv6, they go on IPv6 only. 60% of traffic switched to IPv6 because Google, Facebook is on IPv6, and they did not expect that. They were sort of like, okay, we will just test something, and they deployed IPv6, and it was sort of like a game for them. And all of a sudden, 60% of traffic switched to IPv6. It was like, whoa, hang on, we are not ready for this. Then I told them,
they roll back.
You will have lots of traffic. If you switch to IPv6, you will have lots of traffic. So then they disabled it. They went back to the lab. They learned. They got the experience. And then when they were ready, they switched it on. So it's not some academic game anymore, somewhere in the corner. It's a real thing, right? You need to be ready for this.
I have an explanation why for some people the IPv6 works better than IPv4, and for others don't. From my standpoint of view as a network operator, I see the following situation. You have a congested link with somebody, and the first thing you do when you have a congested link is not to increase the link capacity, but to divert traffic to a longer path to solve the congestion. And you do that for your main traffic, and your main traffic is IPv4. So IPv6 is still going to the shortest spot, but the IPv4 is taking the longer path, and eventually you will have a better experience with IPv6 than with IPv4.
Good.
Yeah, but it depends on you. If you have the same policy for IPv6 as for IPv4, they will both change together. Okay. They talked about it.
Okay, nobody implements the same policy for IPv6 and
you
IPv4. Yes, because 80% is IPv4, and the IPv6 is insignificant to the whole traffic for most ISPs. So they will change the main part of the traffic, and this is still IPv4. So they will change the IPv4, and then IPv6 will be unchanged.
You should have the same routing policy from one reason. You would have unknown problems if you have different. You need to check IPv6 for the problem. IPv4, yes. You have more problems. If you have the same routing policy, once a problem arises, you should.
Yes. If you when I have a peering connection with somebody, okay, and it's congested, so I have to do something. So I have to divert a part of traffic to another path. Okay, to do that, we will check the my biggest customers, and I add BGP prepend to them. Okay, so in this way I solve the problem of congestion, because some of the customer will take the longest route, and some of them will not. And this is happening even if I have IPv4 only. So I have customers which go to the shortest path, and I have customers who will took the longest path. So this already happens for IPv4, and IPv6 is not important, so nobody will try to change for IPv6 if the IPv6 traffic is not significant to IPv4.
What if not all of your peers are IPv6 ready?
You do what you can. There's nothing you can do.
Okay.
A question for Claudio. I wanted to ask you, what do you think is better to learn from your own mistakes or from other people's mistakes? As
Both.
a businessman.
Both. From your own mistake
one
is
is
faster, because you learn as you try.
Do you
From
think-
reading, it's kind of hard. You have to do experiments and see how it works and understand fully by doing something.
I mean, as a businessman, as a person that runs a business, if you are the one that is going to experience these new problems, new issues, then
you will learn faster.
You will learn faster, but you will have some costs. You can lose some customers. You can have some problems.
That's the issue regarding IPv6, right?
Yeah,
Okay.
what you said earlier.
Okay, you have to
encounter a
do
lot
that.
of
You
new
have to do it
problems.
on a level which permits you to understand. You have to be ready for the new technology.
Yeah,
If you don't get ready for the new technology, you will have some costs. Okay, I'll have to buy, I don't know, 1,000 equipments supporting IPv6. I have to assume that cost if I want to be ready in time. You can't do anything about it and just expect to somehow magically work. Nobody's gonna come into your network and implement that. You have to take your time, read, learn, do something in order to be prepared.
Okay.
So, running a network costs. Educating people how to troubleshoot the network and how to run the network costs. Expanding your network costs. Everything costs. So I don't see why this would be, because, you know, IPv6 is not a business upgrade. It's just business as usual. It's a technology update. It's a technology refresh of your network. You just add new protocol. In old times we had, you know how many protocols on the wire? IPX, LAT, DECnet, IP, AppleTalk, many of them. Now, it seems that people is afraid of T. So what seems to be the problem? We need to learn all the time and go forward. Going backwards doesn't help much.
You're right, but what I meant is that the pioneers will have the higher costs, and it's much easier to go to university, to go to college to study, instead of learning by yourself.
First, so have you checked the calendar? It's 2016. First pioneers were done in 2008.
Yeah.
On IPv6. You need to check the calendar.
Yeah, IPv6 has, as I was saying earlier, IPv6 has 18 years. It's 18 years old, but its maturity is...
It's good. So, okay. So you are trying to explain me that T-Mobile USA
is a pioneer.
Has 48 million devices on IPv6 only because the protocol is not mature and ready? Are you trying to say that? I'm trying to say that I just got a note from the biggest Canadian operator, mobile operator. They're enabling all their customers on IPv6 in a week from now. Are you trying to say that it's not ready? Are you trying to say that the whole Africa is implementing, while we speak here, Andrew Alston is implementing tens of millions of users in Kenya and Tanzania and South Africa?
I just see the statistics, the facts, and you can see
Statistics
Akamai, Google, and everybody.
Real life. So, okay, there is a difference. So, in theory, the theory in practice is the same. In practice, there's a big difference between theory and practice.
I like this debate. I don't want to cut you off, but we have a couple of more questions to go through, and I'll say this about pioneers: the world needs heroes. So.
Accurate calendar.
Let me just a minute.
Okay,
yes,
sorry.
we in Romania were the pioneers, even with IPv6. But the result is Romania is decreasing. As, earlier, there was not included in the graphics, but Romania had something like 15-16% adoption rate of IPv6 4 years ago. And now it's 3%, according to Akamai.
Yeah, Ciprian,
So
but
Romania has been a pioneer, has hit the walls, and now is going down.
Ciprian, that's really actually not the case. Some of the companies that advertise IPv6 just removed the advertisement. It doesn't seem, it doesn't, I didn't see that, for example, the providers remove IPv6 from clients. They didn't do that. Just some customers who advertise IPv6 actually remove them from their BGP. And oh, I understand.
Give me a chance to. So he was talking about the measurements from Google and Akamai,
Yeah.
just to so the feed has the sound.
They will increase again.
Okay, I
Okay.
would like to tell the story. There is no statistic or such thing. Also is related with the policy, the same policy applied for IPv4 and IPv6. Don't know that. We were doing that. And during one change, we have modified the policy for IPv4, but we didn't modify it for IPv6. And one IPv6 prefix didn't work for a couple of two weeks, let's say, until a customer suggested that his IPv6 is not working. The same thing happened 2 years after, and it took only 1 day for a customer to say that the IPv6 is not working. So I think the usage of IPv6
It's growing. Yeah.
Okay, that's a good anecdote.
Actually, a problem is that the community of RIPE permitted to sell IPv4, and some of the customers got IPv4 and renounced to IPv6, and that's about it.
And
but that's a small portion.
Who did that
that's not
in
enough.
Romania?
And another
Nobody.
thing happened since 2012. A lot of small ISP were brought, and the new owners imposed the policy, and that policy didn't include IPv6. So that's...
I don't think that's the case in Romania. The largest buyer of smaller ISPs is the one that has deployed the largest IPv6 network.
Yeah.
And this is not the reason. So there is absolutely not the reason of why IPv6 is decreasing in Romania. It's a different one.
It doesn't matter why they are decreased. They will rise up. The most important thing is that the protocol is not broken, and it works. You just have to do it, and that's it.
I'll let you guys continue this after the panel, because we can be here all night. He should. Well, benefits. I want to say that some benefits go beyond just. We've heard an argument that IPv6 only brings a larger number of IPs, and I've heard other people say that benefits go beyond that, and there might be possibilities or opportunities that are not obvious. And in our discussions prior to this panel, prior to this panel, you mentioned something about using IPv6 to get rid of ports. Can you expand on that?
Yeah, so, IPv6 is not just 96 more bits, no magic. It is more addresses. But also, there are other things. You have extension headers that you can do lots of stuff in it. Lots of things were fixed from IPv4. From the protocol point of view, were fixed because there were some architectural flaws that were corrected in a new version of the protocol. So there are some improvements other than just the number of addresses. So just for example, now what some people is thinking about, and I think Google is already working on it. So can you imagine how cool would it be if you could assign a /64, so that's a lot of addresses, to each host. So you have a host, you have a Linux machine or Windows machine or whatever you got, And you got all this huge number of addresses assigned just to this host. And then you start a DNS server, and you assign a unique IPv6 address just to that process. And you start the Apache server, the web server, and you assign the address just to that process. What does this mean? That if I'm trying to get to your content, I'm not anymore addressing the address and the port 80 or 443 for HTTPS. No, I don't need port anymore, because if I want to get your content, the only thing that is running on that IP address is the web server. So I address the address, the IPv6 address, and whatever request comes to this address, it's just one server, just one process to respond, and I get back the content. So that means that we start differentiating services based on IP address, not anymore on ports. This means that security policy, now we are doing on layer 3 and layer 4, right? That means that we can lower the security policy to layer 3. We can do layer 3 in hardware easily. Not every equipment supports doing layer 4 in hardware because it costs, right? Doing the filtering for layer 4, it's much more expensive than filtering simple filters on layer 3. And that's how we can simplify many things, right? You know, this is just an idea that actually some people is already working on, and I think it's cool. I think it will completely change the paradigm of networking that we have been used to. And there are also some other crazy ideas what you can do with IPv6.
I think that in that line of it's not just about the internet like it is now. This is the internet that is coming. There are new things coming that need IPv4 is not enough. It's just not enough. As examples of things that are already standardized and being developed out there with commercial products, we can think about wireless sensor networks, and we can think about home nets. Wireless sensor networks has a protocol called 6LoWPAN that only supports IPv6, and you can have thousands of sensors measuring and sending information between them. You can create a mesh of sensors, and you can use it for measuring your temperature on data center, or the moisture of the soil in a vineyard. There are products out there, and you're not able to do that with IPv4. That's it. And also home nets, the idea is that the end user network is not as simple as just one LAN and Wi-Fi, but could have routers behind the routers that automatically connect and request a prefix, and everything should happen automatically, and you get a complex network inside your home. Your car, your set-top box, different things in there. And the only way of making that possible is using this new protocol. So it's something that, okay, you can stand where you are, but you are not be ready for these future services, because at the end, if you do things right, users, the IPv6 should be transparent for the end user. They only want to access services. So you can sell new services and get money with that if you use IPv6 and you think forward. That's the main idea.
I wanted to ask you a question. We have discussed about these ports last evening, and I want to ask you this. In my company, I don't want my workers, my employees, to be able to connect to SMTP outside of my company. How could I filter that if I don't have ports?
So if you're running your own company, usually the enterprises are running firewalls that are doing layer 7 packet inspection. Let's face it. That's what
it's too expensive for me. I just want to filter ports. It's much easier, and I know how to do it. It's simple. Everybody knows how to filter ports. I don't want to do packet inspection.
I assume this would be like this would be like a configurable option on the host, so you can allow to do this, use an IP instead of a port, or not allow to do this from your company policy.
No. If the outside SMTP server doesn't use a port, then I don't know that my employee would connect directly to an SMTP server.
Why would you want to?
I don't want him to connect directly because maybe their computer gets infected. and they send
Internet
of
is the
traffic.
network where people communicate. Why
Yes,
would
but
you do that?
all the companies do all kind of filtering, all kind of firewall for different reasons.
Ciprian, what Ian was saying is that you can do that. You can put a bind server on an IPv6, a mail server on IPv6. You can get rid of the ports. Okay, I agree with you.
Then my
But in
employee
time,
will
in
connect to
time,
your server
the mail server that you want to filter or the traffic, it will change, it will adapt. You will be able to query the host the mail is going to and just drop that IP. It will change. It's not going to stay the same. We are now blocked in the mentality of IPv4 and ports and stuff like that. It will adapt, it will change, we will find new ways of blocking the traffic.
Exactly.
And so, I'm glad you mentioned the change in mentality.
Can I just add one more thing? Just
Sure, yeah.
an analogy. We are now trapped in this V4 mentality. So the analogy for me is like you know, when they build the first car run on coal. They put the coal in and put the fire, and it was a steam engine, and they were running around with these steam cars. And then somebody came to the idea to switch to gas and diesel. And then these people that were using coal and steam was sort of like, this will never work, right? We will not switch because we have enough coal and we will be able to run our cars
And now we are switching to electric.
Infinitely, right? If people would not think about the future and go through the pain of changing the car from the steam engine into the combustion engine, into the diesel or gas, we will still all be running the steam cars. Would that be of any good to us, or?
Thank you for that analogy. I just have
in Germany, just a second. In Germany, they still use DSL connections of 10 megabits per second. So they are still using steam engines. We have here the average connection of over 100 megabits per second in Romania. So they were not able to change the mentality to move the hardware from something that was implemented 20 years ago to what we have today in Romania. Do you think they are going to move?
I have a neighbor at home that has the steam engine at home.
Let's leave it at that, and I'll ask the final question because there was it's related to this. We've heard arguments that with IPv6 deployment could lead to less security on the internet or more problems on the internet because it provides an opportunity to bring a large number of insecure IoT, Internet of Things devices on the internet. And I know, Alvaro, you touched on this, the rise of IoTs in your talk, so maybe you can address this issue.
There is a big concern when people start learning about IPv6, because there is a big threat of the unknown, but when they start learning about IPv6, you realize you have to change your mindset. You can have IPv4 mindset or IPv6 mindset for specific issues that at the beginning takes time. It's what they have already said about the learning curve. You need to play with technology to learn that things. Two main examples could be addressing. You will see that you will have the feeling that you are wasting addresses with IPv6, but for sure you need to do the math, and you will see you have more than enough addresses. If you go back into the bits, you will see you have that huge amount of addresses that you can even, you can imagine how much you have, so you don't have to be aware of using addresses. And the other one is the security. Everybody with a IPv4 mindset associates the public addresses with being exposed to the internet. And in IPv6, you use public global IPv6 addresses, but having a global addressing doesn't mean you have global reachability. It's not mandatory to have an IP address, and that address is reachable from the whole internet. You are the network manager, you are the security officer. You have to decide who's going to connect to which device. So it's just a change of the mindset, taking that into account, and when you design your network, you have to be aware of that. And it's not more or less secure, but it's a different scenario, and you have to do things a little bit different. That's all. That's my point of view.
And on that note, because we are out of time, I'd like to thank our guests for joining us for this. Hope that you found it informative and you enjoyed it. And if you have any other questions for our guests, I'm sure they'll be around and you can ask them outside. Thank you.
Okay, thank you, Lucian, and everybody, all the panelists. I would like to add, actually, that Lucian preferred to do this rather than go on honeymoon. So he's really, I hope his wife is very forgiving. But, okay, we've just got the one, I say presentation left. It's just a short update on some things related to the IETF. We sort of mentioned already some things about this earlier during the workshop where we touched upon it. Appreciate we're sort of getting towards the end of the day. We're scheduled finish for this this event is 6 o'clock, so I won't keep you too long. I'm going to skip through most of these, but I do just we always do this at an ION conference because we want to raise awareness that actually you know, the IETF is a process that creates the standards and helps create the internet. And actually, it was already mentioned here several times today that you have experience with deployment. If you have run into problems, you run into issues, then provide feedback to the developers, provide feedbacks into the standards process because this is useful for improving the quality of these. So this is really what the point of this is about. Just to say here, although the ISOC does support the IETF, the organisation of the IETF, we don't speak for the IETF. Nobody speaks for the IETF. So the slides here, I'm speaking about the IETF as an individual participant. So, yeah, I think most of you are probably pretty aware of what the IETF is. So this is where a large international community of network engineers, operators and vendors, also academics who come together 3 times per year to meet, to discuss and to develop the various standards, various internet standards. Of course, some of the work never actually becomes a standard as such. Lots of things get dropped by the wayside, but this is all part of the process. But the aim is to eventually come towards producing these open standards known as RFCs. Some of these are well known, some of these are quite obscure, but they define a lot of the things that make the internet work, like the TCP/IP protocol, email, routing protocols, DNS, which we heard about today. Also the web, voice over IP, that's just some of the many that have been produced over the years. But the point is that everyone can participate in the IETF. Even if you can't make it to the meetings, you can participate in the mailing lists and in the discussions. Everybody can submit a draft document, draft standards or draft recommendations. And these go through the internet draft process, which then get debated and discussed either on the mailing list, through the working group chairs, through the area directors, so on. There are, well, at the last count, this may have changed since the last meeting, but about 135 working groups, usually chaired by 2 or 3 different chairs. So there's pretty much something for everybody there, if you have a particular interest. Some of these are very long-running, some of these are less long-running. Many are created, some are recharted over time. Eventually, once the work is finished, some of these are wound up. But the working groups are all organised under 7 areas. And these areas are overseen by either 2 or 3 area directors. That's a quick summary of what the areas are and some of the work that goes on underneath those areas. We won't go into that in too much depth. These slides are available, will be available on our website after this event. And that sort of gives a sort of breakdown of roughly how many working groups are by area. So as I mentioned, meets 3 times per year, moves around the world to different locations. And this is often where work gets discussed that's been discussed previously in the various mailing lists, discussion lists. So the sort of list of where the IETF has been, so it really is sort of distributed in various places around the world. The next one will be in Seoul in South Korea, and then the one following that will be in March next year in Chicago. Anyway, last IETF was held in Berlin, so very convenient for those of us in Europe. Actually had a very, very high attendance, 1,902 registered participants from 65 countries. But when I went through and had a look at this to see how many were for Romania, there were just 2, which is quite interesting. So it's very interesting because Romania is very active in the internet space. You know, we heard today that it's, you know, with IPv6 it's doing well, with DNSSEC it's doing quite well. With internet standards, there's just 2 Romanians went. I don't know if any of them were in the room, any of you in the room here, but what was interesting is there were a lot of Romanian names on that list, but from other countries. I don't know whether everyone emigrates from Romania to other countries or just likes to register as a different country, but just an interesting thing to mention there. You can also follow we do some coverage at ISOC of the IETF. You can follow that. We have various blogs, but we also do a rough guide before each IETF meeting where we try to highlight the things of interest, which we think will be of interest to our community. I already mentioned the next meeting in Korea. I'm going to skip over these working groups. These are the working groups that are relevant to Deploy 360 program. But what I wanted to mention is that we do have an IETF Fellow program, which are available to help people attend IETF meetings. So you can apply for this, you can make your case, and we can provide some funding to attend these meetings. So maybe we can get the number up from 2 people in Romania. There is also another parallel program, what we call Regulators to the IETF. So this is to get essentially policymakers, communications, telecommunications, policymakers to come to the IETF and learn about the IETF standards process. So this is really to familiarize people within governments and those who make the laws, perhaps, or certainly communications policy, to get them to come and attend the IETF, understand how it works, how the process works, and the aim is to sort of have a better understanding of each side in this process. So if you're interested in that, please follow the URL to that. So just to summarize, well, the IETF makes the internet work better. I think that's pretty clear. And it is a very important body for within the internet sort of standards development process. It needs participation though. It's not a closed shop. It encourages more participation, and we encourage you to take part in this as well. With that, I think that's the last one. So that brings us towards the end of the this ION event. We'd like to thank everybody for attending. We'd especially like to thank RONOG for hosting this here. I think we also need to thank Interlan as well, who've been excellent hosts. I know there are other sponsors as well. I think those are going to be thanked in a moment, so I won't repeat it all over again, but those are the sponsors, and we thank them for helping support this event too. And then we'd like to also finally thank Affiliates, who are our ION series sponsors. So they sponsor all of the ION events that we do around the world. So again, thank you to them. So with that, I'd like to hand over to Chris, and he'll say some final words. Thank you.
Okay, so a few words to thank the sponsors, and we mean by sponsors Infoblox, Data Communications, IP Broker, Internet Society, of course, Ripen CC, and Starnet Media. The live feed is coming from Mediasat. And our media partners, Businesswoman, 9 AM News, ITC Media, and Cert.ro.
Thank you very much for hosting us second time in, let's say, Romania. I think I can speak enough loudly. So it was a pleasure that we spent this whole day. I think you are tired, but we have still the event to enjoy together in the evening. So thank you very much, and hopefully see you next year. Thank you.